Hey everyone, I know it's been a long time, but welcome back to the channel. Trust me, today's video is genuinely something special. Our soothing voyage this evening carries us well past the soft background noise of daily existence, deep into the cosmic expanse where celestial bodies experience their enduring, stable narratives. Sometimes these stellar entities conclude their existences in a manner that is decidedly less than peaceful. Initially, the concept of an exploding star might seem intense, or perhaps a bit unsettling. Yet, there is a profound sense of tranquility to be found in this phenomenon when you step back and observe the grander cosmic tapestry. These massive events, despite their raw power, are fundamentally part of a universal rhythm. It is a slow, enduring progression that requires millions, and frequently billions of years to arrive at its ultimate culmination. Before we gently transition into that final cosmic moment, however, I would like to ask you a modest question. From what part of the world are you tuning in right now? And what is the current hour in your specific corner of the globe? Perhaps it is late at night, that peaceful window of time when the world finally begins to hush. Or maybe it is a bit earlier, and you are simply carving out a brief sanctuary of time for yourself before the day presses on. Whatever your circumstances, the timing feels quite appropriate, does it not? We are sharing a tale about the quiet conclusion of stars during a moment when your own surroundings are starting to soften, slow down, and find rest. If you discover that this type of auditory journey brings you peace, or if it serves as a comforting method to decompress, I would be quietly appreciative if you liked this video and considered subscribing. Your gentle support helps this serene little sanctuary reach other listeners who might also be seeking a much slower, calmer pace. Let us commence our story now, not with a sudden burst of energy, but with a concept that is deeply serene. Picture a star in your mind, not merely as a twinkling speck against the dark canvas of night, but as a tangible, colossal, and unwavering presence. This entity has occupied its space for an era vastly outlasting all of recorded human history, and even predating the majority of our world's natural formations. It simply persists in a quiet state of being, radiating warmth, and successfully keeping its own massive structure intact. That concept of keeping intact is truly the essential theme here. Fundamentally, the deep center of any star is a continuous, delicate exercise in equilibrium. A perpetual wrestling match occurs within its depths. This is not a fierce or unpredictable conflict in the way we usually imagine battles, but rather an endless, unwavering exchange of opposing pressures. In one corner there is the force of gravity, perpetually attempting to drag every particle toward the center in order to shrink, condense, and pack the star as tightly as possible. In the opposing corner, there is the force of energy. More precisely, this is the energetic output generated by nuclear fusion radiating outward from the star's deepest core, effectively holding the entire massive structure aloft. Throughout the vast majority of a star's existence, these two monumental forces remain in a state of absolute perfect harmony. In a poetic sense, it almost mirrors the rhythmic breathing of a living creature. While not a literal breath, the systematic cadence is undeniably present. Gravity squeezes inward, nuclear fusion presses outward, and this ongoing negotiation results in perfect stability, a reliable luminescence, and a tranquil anchor in the nighttime heavens. This graceful stalemate can persist for a staggeringly long duration. The Sun, our personal local star, has been engaged in this exact balancing act for roughly 4.6 billion years thus far. Astronomers anticipate it will maintain this steady rhythm for another 5 billion years or so, before any significant transformations take place. Therefore, when we discuss the death of a star, we are absolutely not referring to an abrupt incident on the cosmic timeline. We are, instead, discussing the closing chapter of a remarkably lengthy and exceptionally patient narrative. Yet, this is the precise juncture where circumstances slowly begin to change. Ultimately, even the most steadfast natural systems encounter their absolute boundaries. Deep within the stellar core, the combustible material driving this fusion, which is primarily hydrogen in the beginning, is not an infinite resource. Over the gradual passage of millions and billions of years, that reservoir of hydrogen is incrementally depleted. It forcibly merges to become helium, a transformation that unleashes immense energy. That continuous release of energy is precisely what fuels the essential outward-pushing force. However, as the hydrogen reserves dwindle, a very nuanced alteration initiates within the star. The perfect equilibrium introduces a slight, almost imperceptible waver. It is not an immediate catastrophe. There is no instantaneous cave-in and no sudden blast. Instead, it is merely a progressive, gentle transition. The stellar core begins to shrink ever so slightly because the outward-pushing radiation has lost a fraction of its vigor. The inward pull of gravity slowly begins to reclaim a tiny advantage. This victory does not happen instantaneously, but the shift is substantial enough to alter the star's destiny. When this deep core squeezes inward, a fascinating physical reaction takes place. The temperature within the core escalates. Intuitively, you might assume that squeezing something tightly would just make it smaller and perhaps chillier. Within the heart of a star, however, this tight compression actually drives the internal heat to extraordinary new heights. You can compare it to the act of compressing air inside a bicycle pump. The more restricted the space becomes, the more the temperature inherently rises. Consequently, as the stellar core undergoes this minor contraction, it simultaneously grows much hotter, and this intense new heat paves the way for fresh varieties of nuclear fusion. The accumulated helium can now begin the process of fusing together to create substantially heavier elements. In its own way, the star is improvising, discovering alternative methods to artificially sustain its delicate balancing act. For a specific epoch, this newly adopted strategy is successful. The stellar body physically swells, occasionally stretching to a circumference drastically larger than its original size. It may transition into what the scientific community refers to as a red giant. During this specific era, the star's outermost atmospheric layers billow outward, casting a much softer, crimson-hued glow into the void. Viewed from a great distance, this swollen star appears entirely peaceful and visually stunning. Beneath that serene surface, however, the internal mechanics are turning vastly more intricate. Every successive phase of nuclear fusion yields materials that are increasingly heavy. Hydrogen transmutes into helium. The helium eventually transforms into carbon, which then gives way to oxygen, and the pattern continues. With every forward progression, the star is actively forging much more complicated chemical building blocks within its center. This brings us to a highly crucial detail. Not every stage of nuclear fusion yields an identical return on energy investment. Eventually, the star arrives at a critical threshold where the ongoing fusion reactions simply fail to generate adequate outward force to fight off the crush of gravity. The unwavering stability that preserved the star's shape for eons fundamentally begins to falter. It is not an abrupt failure, but it is a mathematically inescapable one. You can liken it to an ancient, magnificent building that has been lovingly braced for decades, only to slowly experience the decay of its primary weight-bearing pillars. Once that internal architecture degrades past a certain threshold, the force of gravity does not merely take a small advantage, it claims total dominion. From this point forward, the exact narrative arc heavily depends on the sheer physical bulk of the star in question. More modestly sized stars, much like our own Sun, are destined to experience a far more peaceful conclusion. They will gently cast off their gaseous outer envelopes over time, eventually leaving nothing behind but a highly compressed glowing core. Conversely, stars of a much grander scale, those possessing many times the raw mass of our Sun, are bound to a drastically different destiny. This is the precise threshold where the concept of a true supernova truly enters our view. For these gargantuan stars, the final fracturing of their internal equilibrium does not culminate in a silent, fading collapse. It culminates in an event of staggering, violent grandeur. Visualize the deepest heart of this massive star, a region that has spent eons methodically synthesizing increasingly dense elements. Ultimately, this relentless manufacturing process arrives at the element of iron. Iron behaves quite differently from everything that came before it. Unlike the earlier, lighter elements, the active fusion of iron particles does not emit free energy. Instead, the fusion of iron actively drains energy from the surrounding environment. Therefore, the moment the core becomes saturated with iron, the star permanently loses its capacity to project the outward pressure required to keep its own immense weight supported. Nuclear fusion is no longer capable of holding the structure aloft. Gravity, a force that has been biding its time with infinite patience, is suddenly unopposed by any internal resistance. In that exact, defining fraction of time, the entire paradigm shifts. The stellar core initiates a catastrophic structural collapse. This is not a sluggish or delicate caving in. It occurs with terrifying, unfathomable speed. It happens at a velocity that defies anything we could ever witness or replicate on our terrestrial home, within a mere sliver of a single second. The physical matter that once occupied an immense spherical volume is crushed into an impossibly compact space. It challenges the limits of human imagination to properly visualize this. Try to conceptualize an object roughly the dimensions of our entire planet being forcibly smashed down until it is no wider than a standard city. Even that extreme comparison fails to capture the true severity of the compression. The subatomic components residing in the core are shoved so violently together that the standard architectural laws of atoms simply disintegrate. Negatively charged electrons are brutally driven into positively charged protons, merging to form neutral particles called neutrons. The former heart of the star is transmuted into something entirely alien. It becomes an unimaginably dense, hyper-compact sphere composed almost entirely of tightly packed neutrons. However, this is the specific mechanic that elevates a simple collapse into a spectacular supernova. This violent inward freefall does not simply proceed infinitely toward the center. At least, it does not do so in that immediate moment. Eventually, this core reaches such a profound state of density that the laws of physics prevent it from squeezing together even a fraction more. It hits an absolute, unyielding mechanical threshold. When this terrifying inward plunge meets this sudden, immovable roadblock, all of the cascading stellar material violently impacts the rigid center. Following that impact, a truly miraculous physical reaction occurs. The material aggressively bounces backward. That catastrophic inward implosion instantly reverses, becoming a ferociously powerful outward-bound shockwave. This represents a sudden, overwhelming eruption of raw force that tears back out through the star's exterior gaseous layers. This precise outward surge is the actual birth of the cosmic explosion. The sheer volume of energy liberated during this brief window is almost incomprehensible. For a fleeting cosmic moment, this single dying star has the capacity to outshine the combined light of an entire galaxy. This immense brightness is not a result of the star physically growing, but rather the consequence of an unfathomable quantity of energy being dumped into the void simultaneously. To an observer situated light-years away, it manifests as a brilliant, freshly born point of illumination in the night sky where nothing was previously visible. Astronomers of antiquity frequently referred to these phenomena as guest stars, due to their habit of arriving without warning, lingering for a brief season, and ultimately vanishing from sight. In reality, those ancient stargazers were unknowingly witnessing the majestic death throes of a supermassive celestial body. Fascinatingly, while we universally refer to this event as an explosion, it is not simply a matter of an object blowing itself to pieces from the inside out. It is the direct byproduct of a structural failure, a localized victory for gravity, and a subsequent, aggressive physical rebound that propels material into the cosmos. It represents a chain of events that initiates with a nearly silent exhaustion of internal fuel and concludes with an unimaginably radiant display. Yet, even amidst that chaotic brilliance, one can find a distinct sense of cosmic purpose. The vast quantities of matter violently hurled into the interstellar void during this detonation, including all those complex, heavy elements forged over the star's long lifetime, do not simply vanish into the ether. They aggressively disperse, churning and integrating with the vast, empty tracts of surrounding space. These newly liberated materials, including vital elements like carbon, oxygen, and iron, eventually serve as the foundational building blocks for brand new stars and nascent planetary systems. In certain instances, those very same elements eventually evolve into complex biological beings, exactly like you and me. Therefore, looking at it through a literal scientific lens, supernovas are never solely about destruction. They are concurrently the magnificent engines of new beginnings, somewhere deep in the cosmos, long before any spectacular detonation or blinding flash of radiation. A star is currently just executing its silent, timeless duties. It is merely holding its own mass together, projecting a reliable light, and existing in a state that appears beautifully uncomplicated from our distant vantage point. But when you truly quiet your mind and ponder the reality of the situation, you must ask yourself what a star fundamentally is. It is far more than a decorative, glowing speck pinned to the ceiling of the night. It is not merely a pretty celestial marker we point toward on a cloudless evening. It is a massive, tangible entity governed by strict physical laws, featuring complex anatomical structures and turbulent internal processes that execute every single moment of every single day. Because we reside on the solid ground of Earth, it is incredibly easy to forget that a star is completely devoid of a solid surface. It bears no physical resemblance to a rocky asteroid or a terrestrial planet. You could never land a spacecraft on it, nor could you reach out and physically touch its exterior. Even if you possessed the technology to approach it safely, you would never encounter a hard boundary or a distinct horizon in the way your mind might anticipate. In reality, a stellar body is best described as a gargantuan spherical ocean of superheated gas. This sphere consists predominantly of hydrogen, sprinkled with a fraction of helium and microscopic traces of other diverse elements, all perpetually bound together by the relentless embrace of gravity. When I use the word gargantuan, I am attempting to describe a physical scale that the human brain genuinely struggles to process. Consider our own sun, a celestial body categorized by astronomers as remarkably average in size. It is so phenomenally vast that you could comfortably pack more than 1 million Earths inside of its glowing perimeter. Yet, despite being constructed entirely of swirling gas, this immense sphere refuses to simply dissolve and scatter into the frozen vacuum of space. Gravity is the invisible glue responsible for that cohesion. Gravity serves as the great unifier, continuously dragging every wisp of that superheated gas toward the dead center of the sphere. Every single microscopic particle of matter contained within the star exerts a gravitational tug on every other particle, forging an environment of relentless inward crushing pressure. If gravity were the sole physical mechanism operating within this system, the entire star would effortlessly crush itself into oblivion in a matter of hours. Thankfully, it completely avoids that fate. The specific reason it avoids that fate is where the mechanics of astrophysics become genuinely captivating. Buried deep within the invisible, crushing core of the star, a specific process is unfolding that alters the entire physical equation. The ambient pressure and the staggering heat in that central region are so severe that conventional atoms cease to act the way they do on our cool planet. Imprisoned within those brutal conditions, individual hydrogen atoms are squeezed so aggressively together that they physically fuse into one another. They violently combine to birth a new element, helium. And this exact molecular marriage releases a truly staggering burst of free energy. Science has named this elegant, violent process nuclear fusion. It operates on the exact same fundamental physics as a devastating hydrogen weapon. But within the belly of a star, this reaction is beautifully contained and perfectly continuous. It does not manifest as a single catastrophic blast, but rather as a highly regulated, perpetually burning engine capable of running smoothly for billions of years. Crucially, the energy generated by this fusion engine does not simply stagnate in the core. It vigorously shoves its way outward toward the surface. Consequently, the star becomes a battleground defined by two massive, directly opposing forces. Gravity relentlessly attempts to drag the star's mass inward, while the ferocious energy born of nuclear fusion constantly attempts to blow the star outward. When these two monumental forces are locked in a perfect, equal stalemate, the star achieves a beautiful physical condition known as hydrostatic equilibrium. That delicate, unwavering balance is the sole reason a star can exist as a stable, long-term entity in our universe. You might easily visualize it as an endless cosmic game of tug-of-war where neither participant ever manages to gain an inch of ground. Gravity stubbornly attempts to crush the sphere, while fusion desperately attempts to inflate it. As long as those two immense pressures perfectly mirror one another, the star simply persists, glowing with quiet reliability. It is absolutely not a frozen, stagnant block of matter. A chaotic symphony of motion is occurring within every inch of its interior volume. Raw energy is constantly being synthesized. Microscopic particles are aggressively colliding, and vast layers of plasma are perpetually churning. However, if you observe it from the safety of a distant world, it projects an aura of absolute serenity. It appears as nothing more than a calm, unblinking pinprick of light. Now, we must consider a specific cosmic rule that frequently feels a bit counterintuitive to the human mind. The overall physical girth and the dazzling brightness of any given star are primarily dictated by its total starting mass. When a star is born with an exceptionally high mass, it inherently possesses a vastly more powerful gravitational field. That magnified gravitational pull squeezes the star's core with far greater ferocity, which consequentially drives the internal core temperatures to much higher extremes. This amplified internal heat acts as an accelerator for the nuclear fusion process, resulting in the generation of significantly more outward-pushing energy. Therefore, massive, heavyweight stars do not merely glow with greater intensity, they actively incinerate their internal fuel supplies at a much faster pace. This creates a rather poetic and fascinating evolutionary trade-off in the cosmos. A diminutive, lightweight star consumes its hydrogen fuel with extreme frugality, allowing it to stretch its lifespan over billions or even trillions of years. Conversely, a colossal, heavyweight star, the exact variety destined to eventually detonate as a supernova, experiences a violently brief existence. It ravenously devours its available fuel supply in a cosmic blink of an eye, frequently burning out completely in just a few million years. It is remarkably similar to comparing the gentle, flickering flame of a small candle to a massive, roaring bonfire. The small candle burns with quiet restraint, ensuring its waxy fuel lasts for a highly extended period. The massive bonfire burns with ferocious, blinding intensity, but it thoroughly exhausts its wooden fuel supply in a fraction of the time. Stars adhere to a virtually identical set of behavioral rules regarding fuel consumption. This distinction is incredibly vital because it dictates that not every star in the sky is hurtling toward the exact same magnificent doom. Only the absolute heaviest, most massive stars, the ones that burn with reckless abandon and live furiously brief lives, harbor the extreme internal conditions necessary to eventually collapse and trigger a supernova. More diminutive, ordinary stars, like the gentle yellow sun warming our world, are locked onto a much different, remarkably less explosive trajectory. Before we delve too deeply into the mechanics of stellar death, however, it is highly beneficial to linger a bit longer on the nature of a star during its stable years. Even amidst its calmest, most enduring epoch of life, a star is a mechanism of staggering complexity. The raw energy forged deep within its crushing core does not instantly teleport to the star's outer surface. It can actually require thousands, and occasionally hundreds of thousands of years, for a single packet of energy to successfully navigate its way from the core to the exterior. It must painstakingly migrate through thick layers of plasma, ricocheting endlessly off of densely packed particles, slowly fighting its way toward the vacuum of space. Once that resilient energy finally breaks free of the star's surface, it radiates outward into the empty cosmos as both visible light and radiant heat. That exact energy is the golden sunlight we experience on a warm afternoon here on Earth. It is the comforting heat you feel soaking into your skin on a perfectly cloudless morning. It is the vital illumination that permits forests to grow, that orchestrates global weather systems, and that anchors biological life in ways we rarely stop to appreciate. Every single aspect of that life-giving energy originates inside the crushing core of a distant star, born from microscopic fusion reactions executing on an endless loop. In a deeply philosophical way, it is a remarkably quiet, industrious process. There are no erratic explosions, no terrifying optical flashes, merely a stubborn, unwavering stream of energy projected across unfathomable gulfs of time. Yet, completely hidden within that reliable steadiness, the ultimate destiny of the star is actively being written. This is because every individual fusion event permanently alters the chemical makeup of the core by a microscopic fraction. Hydrogen is irreversibly transmuted into helium. The sheer volume of helium slowly but surely accumulates at the center of the sphere. With the relentless march of time, the internal equilibrium of the stellar body shifts in a profoundly subtle manner. It is absolutely not an alteration you could ever witness by casually glancing at the night sky. It certainly isn't noticeable on any timeline that makes sense to a human lifespan. But when stretched across the epic canvas of millions or billions of years, those microscopic chemical changes begin to compound heavily. The star fundamentally evolves. This specific concept of slow, inevitable evolution is paramount to understanding the cosmos. A star is never a static, unchanging monument in the heavens. It possesses a distinct, measurable life cycle. It coalesces from dust. It achieves a long plateau of stability. It slowly mutates, and it invariably arrives at an ultimate conclusion. The nature of that final conclusion is completely governed by the star's total mass, its rate of fuel consumption, and the shifting tug-of-war between gravity and nuclear fusion. Yet, at its fundamental heart, across all of these sprawling evolutionary eras, the true definition of the star remains remarkably consistent. It operates as a spectacular theater where the forces of gravity and energetic radiation engage in endless, high-stakes diplomacy. It is an unparalleled cosmic forge where basic matter is subjected to radical, irreversible transformation. It is an environment where the most basic, rudimentary element in creation, hydrogen, is methodically sculpted into materials of vastly greater complexity. Furthermore, this ongoing elemental alchemy does not solely impact the solitary star in question. With enough time, these glowing spheres effectively function as deep space manufacturing plants for the heavy elements. The carbon molecules that build your cellular structure, the oxygen atoms filling your lungs, the iron molecules carrying oxygen in your veins. Every single one of these components was forged inside a star in the deeply ancient past. Consequently, when we direct our gaze toward a twinkling star, we are observing much more than a bright, distant anomaly. We are literally witnessing the very mechanical process that, in a highly practical sense, authored the existence of our entire world. While that concept feels immensely profound and deeply philosophical, it remains a surprisingly quiet, patient reality. This is because it progresses at a sluggish pace across timelines so utterly expansive that the human mind simply cannot fully encapsulate them. There is absolutely no sense of cosmic panic or urgency involved. There is no hurry. There is only a steadfast, unyielding progression. Within that slow progression, the great balancing act is always diligently at work. Gravity tirelessly attempts to pull the celestial fabric inward, while nuclear fusion tirelessly pushes the fabric outward, forging a constant, delicate negotiation between implosion and expansion. Provided that this internal negotiation remains successful, the star endures, broadcasting its steady light and appearing perfectly immutable to our distant eyes. However, as we previously acknowledged, this perfect equilibrium is not an infinite condition. The nuclear fuel chemically changes, the internal pressures and temperatures fluctuate, and invariably the precise forces that maintained the star's harmony begin to drift out of alignment. This failure of balance does not strike like a bolt of lightning. There is absolutely no instantaneous flip of a switch from peaceful stability to violent catastrophe. Instead, it manifests initially as something incredibly nuanced, a minor imperfection in the balance, a slow, creeping mutation within the core. It is the variety of physical shift that in its earliest stages seems entirely inconsequential. But as the eons roll by, that microscopic deviation expands, quietly arranging the chess pieces for the magnificent destruction that is destined to follow. If you possess the magical ability to observe a star's entire lifespan from birth to death, not by blinking up at the sky, but by artificially accelerating time just enough to witness its evolution, you might actually be shocked by how mundane the majority of it looks. It would not be an empty or pointless viewing experience, but it would appear deeply consistent, highly reliable, and almost meditative in its patience. This is because, for the overwhelming majority of its tenure in the universe, a star is not exploding, caving in, or executing any sudden theatrical maneuvers. It is merely enduring, preserving its spherical geometry, managing its internal equilibrium, and quietly transmuting basic elements into heavier ones, second after second, millennium after millennium. It does this for durations of time so unfathomably vast that merely trying to conceptualize them requires a great deal of mental gymnastics. That incredibly long, highly stable plateau is precisely where the bulk of any star's biography is written. To truly grasp the essence of a star, it is highly beneficial to ignore its violent finale and its initial collapse, and focus entirely on its long, uneventful middle chapter. Once a young star has fully coalesced, moving past the chaotic early era where massive clouds of space dust slam together and gravity compresses the entire structure, it relaxes into a phase astronomers label the main sequence. It is entirely unnecessary to memorize that specific piece of jargon, as the underlying concept is beautifully simple. This is the era of profound stability. This is the chapter of the star's existence where the internal forces are existing in near-perfect harmony. Deep inside the crushing core, hydrogen atoms are actively being fused together to birth helium. This microscopic fusion releases a steady stream of energy, and that energy shoves outward, physically lifting the immense weight of the star against the relentless inward drag of its own gravity, as long as a sufficient reservoir of hydrogen remains inside the core, and as long as the crushing pressure and extreme heat remain high enough to facilitate that fusion, the star happily lingers in this comfortable state. This specific phase of stellar life can persist for an almost incomprehensible amount of time. For the absolute smallest, lightest stars in the cosmos, this era of stability can stretch for trillions of years, a span of time far exceeding the current estimated age of our entire universe. For a medium-sized star exactly like our Sun, this stable middle chapter lasts for approximately 10 billion years. For the absolute largest, most massive stars, the specific celestial giants destined to self-destruct as supernovas, this stable window is drastically truncated. Their main sequence phase might last a mere few million years, or perhaps a few tens of millions of years. While that is a fleetingly brief window by cosmic standards, it is still an unimaginably massive stretch of time from a human point of view, regardless of the precise mathematical duration. The core behavioral traits of this stable phase are nearly identical across all varieties of stars. There is a distinct, almost comforting routine to the way the star conducts itself. Raw energy is constantly synthesized deep within the core, and it patiently fights its way up toward the exterior. The outer atmospheric layers glow intensely, shedding the generated energy deep into the blackness of space. The star successfully regulates its own physical circumference, its overall luminosity, and its complex internal architecture, experiencing only the most microscopic, nuanced changes over vast epochs. If you were observing it from a neighboring solar system, you might easily believe that absolutely nothing of interest was happening beneath its surface. But beneath that glowing exterior, the environment is defined by relentless, chaotic motion. At the very center of the core, the specific arena where nuclear fusion reigns supreme, the physical conditions are terrifyingly extreme. Ambient temperatures easily soar into the millions of degrees. The localized crushing pressure is entirely beyond human comprehension. Within this hellish, hyper-pressurized environment, individual hydrogen nuclei, which are essentially solitary protons, are violently and repeatedly slammed into one another, Under standard terrestrial conditions, hydrogen atoms possess zero desire to physically merge. Their positively charged protons naturally repel one another, acting much like opposing magnets. However, deep within the belly of a star, the ambient heat is so intense that these particles are hurtling around at unfathomable velocities. Velocities high enough to occasionally shatter that natural magnetic repulsion. When they finally collide with sufficient force, they successfully fuse. That successful fusion event triggers a release of raw energy, and it simultaneously manufactures a new molecule of helium. Consequently, over the slow march of deep time, the chemical composition of the stellar core is subjected to a massive, irreversible transformation. In the beginning, this core is composed primarily of hydrogen, but as the fusion engine hums along, reserves of helium steadily begin to stockpile. This elemental transition does not occur with any sense of urgency. It is certainly not a mutation you would be capable of noticing over any brief window of time. Yet, as millions and eventually billions of years tick by, the cosmic equilibrium definitely shifts, and this remains a crucial concept to grasp. The lifespan of a stellar body is never truly a stagnant affair. Even throughout its most peaceful and dependable era, the star is in a perpetual state of evolution. It transforms at a glacial pace, unfolding with extreme subtlety, yet it never truly stops. The vast ocean of hydrogen within the deepest center inevitably diminishes. Simultaneously, the sheer volume of helium within that same space continually multiplies. The internal environment of the core must constantly recalibrate itself to accommodate this newly shifting reality. The ambient heat, the immense pressure, and the structural density all play a role. Every one of these physical variables fluctuates by microscopic degrees in a desperate bid to uphold the truce between nuclear fusion and the crush of gravity. You might picture it as a massive, intricate machine that is perpetually tuning its own gears to prevent a catastrophic breakdown. Whenever one side of the cosmic scale tips, the opposing side immediately formulates a response. If the rate of fusion lazily decelerates due to a dwindling hydrogen supply, the unrelenting force of gravity squeezes the core just a fraction tighter. This sudden, involuntary squeeze instantly drives the internal temperature upward, which subsequently forces the fusion engine to accelerate once again. To reiterate, it functions as an astonishingly elegant, self-regulating mechanism for an incredibly vast expanse of time. This built-in safety feature operates flawlessly. The glowing sphere remains resolutely anchored in its stability. It projects its warm illumination without faltering. It proceeds through the chapters of its existence in a manner that, to any distant onlooker, feels completely permanent and unchanging. However, this enduring stability is entirely reliant upon one irreplaceable resource above all others. That resource is combustible fuel. Provided that an ample bounty of hydrogen remains trapped in the core, the fusion reaction can persist, and just as long as that fusion reaction persists, its outward-pushing energy successfully keeps gravity at bay. Thus, the magnificent star continues to live. This logic circles us perfectly back to the foundational concept of stellar mass. The total quantity of fuel a star begins its life with, alongside the ravenous speed at which it consumes that fuel, is entirely dictated by how massive it is. A more petite star possesses significantly less overall mass, which directly translates to a much weaker gravitational squeeze upon its core. That weaker inward pressure naturally yields cooler internal temperatures and a wonderfully sluggish rate of nuclear fusion. Therefore, it sips its hydrogen reserves with incredible delicacy, stretching its luminous lifespan out over a staggering eternity. A massive, heavyweight star, conversely, harbors a vastly more muscular gravitational field that severely crushes its internal core, driving temperatures to hellish extremes. In this brutal environment, fusion occurs at a terrifyingly rapid pace, unleashing glorious amounts of energy and simultaneously devouring its fuel reserves at an alarming rate. Consequently, despite beginning its cosmic journey with a much larger fuel tank, a massive star incinerates that fuel so aggressively that its total lifespan is shockingly brief. It closely resembles attaching a truly massive gasoline reservoir to a ridiculously overpowered high-revving engine. You may technically possess more combustible liquid at the starting line, but you are detonating it so rapidly that your journey will undoubtedly be a short one. This is the exact reason why the colossal stars, the specific ones fated to erupt as supernovas, experience such relatively fleeting existences. They burn with a fierce, uncompromising intensity. They illuminate the darkness with blinding radiance, and as a direct result, they exhaust their core materials swiftly. Now, throughout this exceptionally long plateau of stability, the star is actively conversing with its surrounding neighborhood, even if it appears to be sitting in silence. It obviously projects visible light, but it simultaneously hurls physical particles into the void. These are known as stellar winds, which are essentially surging rivers of electrically charged particles flowing aggressively away from the star's atmospheric boundary. These invisible gales possess the power to physically sculpt the empty space surrounding the star, blowing away loose cosmic gas and floating dust, directly impacting how neighboring stars and infant planetary systems might form. Therefore, even in the midst of its most tranquil era, a star is never truly an isolated island. It is an active participant in a much grander ecosystem, serving as a vital gear in a colossal machine that is perpetually shifting, even if those shifts crawl at a snail's pace. Furthermore, there is another profound concept we must contemplate. We must consider the actual flow of time. Not in the frantic way humans experience it, but in the majestic way it applies to a celestial body. For a human being, the passage of time feels like a straight line moving with immediate, relentless urgency. We watch individual days expire. We observe weeks vanish. We count the passing years, and we clearly witness the physical changes they bring. But for a glowing star, particularly one that is destined to exist for billions of consecutive years, the concept of time operates on a completely alien wavelength. What a human mind would classify as an agonizingly long historical epoch might represent nothing more than a microscopic fraction of a star's total biography. This stark reality means that the vast majority of a star's internal functions proceed with such agonizing slowness that from our fleeting vantage point, the celestial object appears practically frozen in amber. However, that deceptive stillness absolutely does not imply that the system is dormant. It simply signifies that the intricate mechanical processes are stretched out across timelines so phenomenally huge that they evade our immediate perception. Nevertheless, every single one of those sluggish, hidden processes is deliberately marching toward a final destination. The methodical hoarding of helium deep inside the core, steady evaporation of the hydrogen reserves, the microscopic tweaks to internal heat and density, every single one of these factors is a necessary stepping stone in an incredibly long, unbroken chain of events. It is a slow, relentless progression that inevitably escorts the star to an ultimate, irreversible crossroads. In the beginning stages, this monumental crossroads is completely hidden from view. The star continues to happily project its light into the dark. From any exterior perspective, it projects an illusion of perfect structural health, yet deep inside, the grand equilibrium is growing increasingly exhausting to uphold. The chemical recipe of the deep core is fundamentally altering. The essential combustible fuel is running dry, and the elegant machinery that has successfully regulated the star for eons begins to bump aggressively against its physical limitations. It is by no means an abrupt or spectacular breakdown. It is far more akin to a lazy, quiet drift toward ultimate instability. It is the specific variety of structural decay that would only become apparent if you had the luxury of analyzing the star continuously for millions of years. But when viewed through any shorter or human-scale lens, this creeping instability remains entirely undetectable. Regardless of our inability to see it, the decay is undeniably occurring. It quickly becomes evident that the serene, slow-paced existence of a star is not merely a peaceful backdrop to the cosmos. It is the foundational bedrock. Everything that subsequently unfolds, every catastrophic cave-in, every blinding detonation, every theatrical cosmic event, is entirely predicated upon the specific environment cultivated during this incredibly long, stable epoch. Therefore, before the narrative shifts into something substantially more chaotic and noticeable, it is worth preserving that mental picture of a star basking in its prime. Beautifully stable, perfectly balanced, and radiating with quiet dignity. Eventually, without any grand theatrical warning or sudden cosmic alarm, the dependable cadence that has shepherded the star through the vast majority of its life begins to falter. It does not unravel all at once, nor does it collapse in a manner that would be remotely visible to someone casually gazing up at the nighttime canopy. Viewed from a vast distance, the sphere continues to glow. It maintains its grand spherical geometry. It projects an aura of stability that seems just as robust as it ever was. Yet, hidden far beneath that glowing skin, the foundation is actively relocating. This profound shift originates from a remarkably basic physical problem. The vital combustible fuel that has been driving the star's engine for ages is slowly, irrevocably running dry. For millions or perhaps billions of years, the hydrogen sequestered in the core has been cheerfully fusing into helium, radiating necessary energy and flawlessly preserving the fragile truce between the crushing weight of gravity and the lifting power of radiation. It has operated as a remarkably dependable mechanism, one that has anchored the star in a state of grace through virtually its entire biography. However, the universe's supply of hydrogen is finite, even within the belly of a true stellar giant, even within a star that sparked to life with a preposterously large fuel reservoir. The central core incrementally finds itself depleted. It is not entirely barren, nor is it completely hollowed out, but the reserves have dwindled enough that the internal climate begins to noticeably change. In the earliest stages of this crisis, the discrepancy is highly nuanced. The overall speed of the fusion reaction decelerates just a fraction. It is not a severe enough drop to trigger an instantaneous collapse, but it is certainly enough to disrupt the ongoing stalemate. This is because that specific outward pushing force birthed by fusion is the only thing keeping the crushing grip of gravity in check. When that lifting force begins to wane, even by the most microscopic margin, the unrelenting power of gravity begins to squeeze the core with a slightly firmer grip. Consequently, the deepest center of the star shrinks inward by the tiniest degree. This is not yet a catastrophic freefall, nor is it a theatrical implosion. It is better described as a delicate, involuntary tightening. It is the exact type of internal settling that would pass completely unnoticed unless you were peering directly into the star's hidden molecular architecture. But when this central core physically shrinks, an incredibly important physical phenomenon is triggered. The core begins to drastically heat up. This reality might appear entirely backwards at first glance, but within the physics of a star, violent compression directly translates to soaring temperatures as gravity forcibly drags the stellar matter deeper inward. The individual particles are jammed into a far tighter space, causing their physical collisions to become violently energetic. Therefore, the ambient heat within the core skyrockets, and this sudden surge in temperature unlocks the door for a completely new chapter of nuclear fusion. The accumulated helium, which has been passively piling up as the waste product of hydrogen fusion, is now capable of igniting and fusing into much heavier materials like carbon and oxygen. This specific chemical reaction mandates vastly higher ignition temperatures than hydrogen fusion, which neatly explains why it remains dormant until this later chapter of the star's life. In a very real sense, the stellar body is actively improvising. As its primary hydrogen fuel tank runs on empty, it successfully locates an alternative energy source to burn. For a temporary window of time, this clever adaptation successfully restores the broken equilibrium. The fusion engine roars back to life, generating fresh energy, pushing violently outward, and effectively halting gravity's aggressive advance. The star achieves stability once again, although this new version of stability looks quite different from its youth. This is because, while the core is now busy incinerating helium, the massive outer atmospheric layers of the star are forced to react to these shifting internal dynamics. The outer envelope physically balloons outward, the star swells to a gargantuan size, frequently becoming exponentially larger than it was during its earlier, more stable epochs. As this outer surface stretches further away from the hot core, it actually cools down by a small margin, bathing the star in a softer, distinctly reddish glow. This is the specific evolutionary chapter that astronomers frequently dub a red giant, although the precise mechanics can fluctuate based on the original mass of the star. If you could view it from the outside, it might look almost idyllic, a massive, softly glowing orb, painted in crimson, boasting a more hazy, diffused silhouette. But beneath that seemingly peaceful exterior, the internal mechanics are becoming frighteningly convoluted. The deep core has ceased to be a straightforward, uniform chamber where a single variety of fusion dictates the rules. Instead, it begins to segregate into distinct layers, creating completely different zones where various types of fusion ignite, based entirely upon localized pressure and heat. You might find residual hydrogen still happily fusing in a spherical shell wrapped around the core, while the newly ignited helium burns fiercely much deeper inside. As the cosmic clock continues to tick, even denser, heavier materials can begin to forge themselves within the absolute deepest pockets of the center. The internal structure rapidly morphs into an intricate, multi-layered onion, and with the addition of each new burning layer, with the initiation of each heavier stage of fusion, the star drifts further and further away from the simple, elegant harmony it once possessed. Because here is the cruel, inescapable truth of stellar physics. Every newly unlocked variety of nuclear fusion is inherently less efficient at outputting usable lifting energy. The burning of hydrogen is a wonderfully stable, incredibly long-lasting endeavor. The burning of helium demands far hotter temperatures and exhausts its fuel supply at a much faster, less sustainable pace. The fusing of even heavier elements executes at a terrifyingly rapid speed, ultimately yielding a vastly inferior amount of the vital outward pressure required to keep the star inflated. Consequently, the star traps itself in a desperate scenario where it must labor increasingly harder simply to maintain a basic level of balance. Gravity remains an ever-present, unrelenting, and utterly constant threat. However, the internal fusion reactions tasked with holding that gravity at bay are steadily losing their potency. This is the exact threshold where the fragile balance begins to slip in a truly meaningful, dangerous way. It completely ceases to be a state of perfect, harmonious equilibrium. It devolves into a panicked system that is perpetually scrambling to adjust itself, desperately trying to bandage over its own internal flaws, while slowly, inevitably losing the battle. The deep core aggressively shrinks. Its temperature spikes violently. A brand new stage of fusion reluctantly ignites. The star puffs outward slightly. It catches its breath for a brief moment, and then the vicious cycle begins anew. With every subsequent repetition, the catastrophic changes unfold with increasing speed. Every new stage of burning is remarkably shorter in duration than the one that preceded it. If the star's initial stable main sequence era dragged on for millions or billions of years, the desperate helium-burning chapter might be over in a fraction of that time, and the advanced stages that follow, where increasingly dense elements are hastily forged together, can be breathtakingly brief by comparison. For the absolute most massive stars in the universe, these agonizing final stages can literally play out over the span of a few days, or, incredibly, a mere handful of hours. However, our narrative has not quite reached that frantic precipice just yet. At this current juncture, the glowing giant is still fiercely clinging to life, continually improvising, and successfully preventing gravity from claiming a total, undeniable victory. Nevertheless, the grim trajectory of this evolution is impossible to ignore. The central core is growing heavier and more densely packed by the minute. The internal ambient temperature is skyrocketing. The chemical recipe of the star is heavily slanting toward the densest, heaviest elements available. And with every single one of these desperate internal adjustments, the fusion engine's ability to conjure up sufficient lifting pressure becomes severely crippled. It closely resembles a complex machine hopelessly burning through its emergency backup generators. In the beginning, the system hums along without a single hiccup. Then, minor recalibrations become necessary to keep the lights on. Soon, those minor recalibrations morph into frantic, continuous adjustments that strain the machinery to its breaking point. Invariably, the battered system arrives at a terminal threshold, where no amount of desperate adjusting can save it. But just before that terminal breakdown occurs, there exists a twilight era where the star hangs suspended in a highly delicate, deeply unstable limbo. It is not yet collapsing into the abyss, nor is it detonating into the void, but it has completely abandoned any genuine claim to stability. This is the specific window where the entire atmosphere of the star begins to feel palpably different. If you were gifted with the ability to scrutinize this star intimately over a long stretch of time, you might start to witness peculiar shifts in its luminosity, watching it suffer minor brightness fluctuations as its internal engines sputter and shift. You might actively observe strange behaviors in its outer atmospheric layers, catching them expanding and shrinking in direct response to the violent chaos echoing deep below. Yet, these remain remarkably subtle omens, lacking any grand theatrical flair that would scream of an impending apocalypse. Because to the casual observer viewing from the safety of deep space, the star stubbornly continues to exist, stubbornly continues to shine, and generally continues to look like a perfectly ordinary celestial body. And that deceptive calm is precisely what makes this specific evolutionary chapter so profoundly captivating. The most critical, life-altering mutations are unfolding completely out of sight. They are buried deep within the crushing dark of the core, where the physical conditions are mutating into something nightmarish, and where the fragile harmony that once defined the star is silently crumbling into something chaotic, unstable, and ultimately doomed. As we patiently trace the arc of this cosmic process, it becomes blatantly obvious that this slipping equilibrium is never a spontaneous tragedy. It is an incredibly sluggish migration, a long, drawn-out march toward a final destination where the star simply lacks the strength to hold its own weight up any longer. It is a terminal destination where gravity, the invisible force that has been quietly waiting in the wings since the star's birth, finally steps out of the shadows to claim absolute authority. Once that invisible line in the sand is crossed, the subtle, slow-moving mutations abruptly shift into high gear. The central core begins to cave inward at a terrifying, accelerated pace. The internal heat spikes with alarming, sharp intensity. The desperate fusion reactions flounder and choke as they attempt to keep the crushing darkness at bay. The dying star hurtles ever closer to an unbreakable threshold. It is a catastrophic threshold where the delicate balance doesn't merely slip an inch, it shatters completely. But before that structural integrity completely disintegrates, we must pause to examine a few remaining chapters, a few final stepping stones in this incredibly long cosmic march. Because the ultimate crushing collapse, the singular moment that births a dazzling supernova, is never the product of one isolated mishap. It is the grand culmination of absolutely everything that has transpired within the star up to this exact point in time. Every single microscopic fusion event, every tiny structural shift deep within the core, every nuanced imperfection that silently compounded over the eons. All of these countless variables are blindly marching toward a singular moment that, upon its arrival, will feel shockingly abrupt, yet in truth, was an inevitability millions of years in the making. There frequently exists a distinct window of time within many slow-moving, complex systems where everything appears perfectly functional at a casual glance. And yet, if you possessed the exact knowledge of where to point your gaze, you would immediately begin to spot tiny, nagging inconsistencies. These are not spectacular, blazing failures, nor are they claxons demanding your immediate intervention, but rather hushed whispers suggesting that the reliable normalcy of the system is failing. A massive star creeping toward its final collapse transitions through a phase exactly like this. Viewed from a neighboring galaxy, it still beautifully masquerades as a healthy star. It radiates its warm light into the freezing void, It seemingly maintains its grand spherical geometry, and it tirelessly broadcasts raw energy outward exactly as it has done for millions of years. If you were simply a passive observer gazing upward without the aid of sophisticated instruments or centuries of collected data, you would never harbor a single suspicion that anything was amiss. But deep within the belly of the beast, the landscape is mutating in ways that leave distinct, undeniable fingerprints. These are not roaring sirens or glaring warning lights, but rather silent distress signals indicating that the beautiful equilibrium we discussed earlier is stretching to its absolute breaking point. One of the primary concepts to grasp at this stage is that the deepest core of the star has entirely lost its simple, elegant nature during the dawn of its life. Back when the burning of hydrogen was the only game in town, the internal architecture was wonderfully uncomplicated. There was a singular, centralized chamber where nuclear fusion happily sparked, wrapped snugly in thick blankets of plasma that effortlessly ferried that energy outward. That beautiful simplicity made the preservation of stability a relatively effortless task. But in the present day, as the aging star has violently bulldozed its way through numerous desperate stages of fusion, the core has mutated into a heavily stratified labyrinth. Distinct, nested shells of burning matter now exist at wildly varying depths, with each unique shell dedicated to forging entirely different elements. We might easily discover a thin ribbon of hydrogen still desperately burning near the outer edges of the core, while a thick layer of helium incinerates violently just beneath it, plunging even deeper toward the true center. Increasingly dense materials like carbon, oxygen, neon, and various others could be frantically fusing within their own localized, pressurized infernos. The internal geography transforms into a bizarre, nested configuration, bearing a striking resemblance to the countless layers of a cosmic onion. And every single one of those distinct burning shells is forced to operate under vastly differing environmental rules, battling unique temperatures, managing wildly varying pressures, and generating energy at completely different speeds. In the earliest stages of this layered madness, this complex architecture manages to hold the star together reasonably well. Each individual, burning shell chips in its own small contribution to the grand outward pushing pressure, pooling their strength to successfully hold gravity back. However, as the deepest, innermost layers become choked with incredibly heavy, dense elements, the overall efficiency of these desperate fusion engines plummets. The forcible merging of heavy, complex elements yields a pitiful amount of free energy relative to the immense physical effort required to sustain the reaction. This brutal math dictates that the star is now forced to labor exponentially harder just to achieve the exact same lifting effect it once managed effortlessly. Now, this is precisely the moment where the silent, creeping warning signs begin to bleed into reality. The massive star fundamentally begins to lose its grip on its ability to smoothly regulate its own internal thermostat. Back in its youth, if the fusion engine lazily dipped in power, gravity would naturally squeeze the core, spike the heat, and smoothly rev the fusion engine back up to speed. It was an incredibly reliable, self-correcting, and highly stable feedback loop. Minor structural hiccups were erased almost instantly by the system itself. But in this chaotic, advanced chapter of life, that reliable feedback loop becomes erratic and untrustworthy. The internal recalibrations are no longer executed with buttery smoothness. Instead of boasting a rock-solid, steady regulation, the aging star begins to suffer from uncomfortable, jittery fluctuations. These physical jitters can occasionally manifest themselves as incredibly nuanced shifts in the star's overall brightness. We are not talking about massive, theatrical flickers, anything that would cause the star to visibly strobe in the night sky, but rather microscopic, restless variations. It is the specific flavor of variation that would only reveal itself to an astronomer, meticulously logging the star's luminous output over an extended duration. It is as though the celestial giant can no longer hold its hand perfectly steady. There is a newly introduced, undeniable erraticness to its energetic output, and that erraticness is a direct mirror reflecting the violent chaos churning miles below. An additional warning flare arises from the bizarre behavior of the star's atmospheric outer layers as the deep core grows increasingly compacted and hellishly hot. The distant outer regions of the star can begin to physically heave, expanding and deflating in direct sympathy with the core. These physical undulations are not overly violent, but they possess the power to actively warp the star's physical circumference and its surface temperature over a long timeline. Consequently, the dying star might visibly puff up, momentarily catch its balance, and then awkwardly shift its weight once again. If you were observing these slow-motion spasms from a neighboring system, it might resemble a slow, laborious breathing or pulsing. Again, it is never a dramatic or violent thrashing, but it is undeniably noticeable if you have the patience to monitor the situation for years. These physical, rhythmic pulsations serve as an undeniable red flag that the star's internal architecture has completely abandoned any pretense of perfect equilibrium. The battered star is desperately trying to shuffle its weight, fighting tooth and nail to recapture its lost balance. But it is doing so with a rapidly compounding sense of futility. Furthermore, there is an entirely invisible, yet spectacularly important, process occurring deep inside the core that refuses to broadcast itself on the surface. This is the massive, silent production of particles known as neutrinos. Neutrinos are unbelievably tiny, effectively weightless subatomic ghost particles that are birthed in staggering quantities during highly specific, violent nuclear reactions. They possess the bizarre trait of interacting almost 0% with ordinary physical matter, which allows them to phase directly out of the star's crushing core almost instantaneously, actively stealing massive amounts of energy as they flee. During the youthful, stable epochs of a star's biography, energy generally escapes the core in the slow, agonizing form of radiation, taking eons to bump its way to the surface. But as the star enters these desperate final chapters, the mass production of ghostly neutrinos becomes a dominant, critical factor. And simply because these neutrinos can slip through solid matter so effortlessly, they act as an aggressive, invisible drain, sucking vital energy directly out of the core without ever contributing a single ounce of outward pushing pressure to help support the star's weight. Therefore, the stellar core begins to hemorrhage its precious energy at an alarming, accelerated rate. Not in a visually spectacular, but in a silent, deadly manner that actively sabotages the star's internal truce. You can picture it as a massive pressurized system that has sprung a quiet, invisible leak, and that steady loss of pressure is making it exponentially harder to keep the walls from caving in. Simultaneously, the chemical recipe brewing inside the core continues its relentless, irreversible mutation. Increasingly heavy, stubborn elements begin to stockpile, actively shoving the star ever closer to an unbreakable point of no return. And it is right here, at this exact precipice, that the cosmic timeline begins to violently fast forward, whereas the star's youthful chapters lazily stretched across millions or billions of years. These agonizing final stages can blur past with terrifying speed. The frantic fusion of carbon might manage to drag on for a few measly centuries or perhaps a couple of millennia. The desperate incineration of neon could potentially burn itself out in just a few short years. The fusion of oxygen might only buy the star a few additional months of borrowed time. And the absolute final, desperate gasp, the stage where silicon is frantically fused to forge iron, can literally ignite and expire over the course of a few incredibly tense days. Just a handful of days. Following millions of years of rock-solid, unwavering reliability, the massive star suddenly finds itself sprinting toward its own demise at a genuinely blistering pace. And yet, astonishingly, if you were to look at it from the outside, it would still appear to be a perfectly normal, functioning star. This is undeniably one of the most chilling and fascinating characteristics of this terminal stage. The absolute most catastrophic, life-ending mutations are executing deep within the hidden core on a timeline that is practically a blink of an eye compared to the star's overall age, while remaining totally concealed from the outside universe. Thus, the doomed star stubbornly continues to broadcast its light, stubbornly continues to occupy its space in the heavens, even as it actively hurdles toward a moment where its own structural integrity will completely evaporate. Additionally, A severe, chaotic imbalance begins to plague the various onion-like layers within the core. Every distinct, burning shell of matter generates its own localized energy at its own unique pace, and these varying speeds can fluctuate completely independently of one another. This erratic behavior breeds deep internal instability, creating chaotic scenarios where one burning layer aggressively expands while a neighboring layer violently shrinks, sparking a hurricane of complex, unpredictable motion deep within the star. It has completely ceased to be a simple, beautifully regulated piece of cosmic machinery. It is now a highly volatile, shifting, panicked structure, desperately trying to juggle its own immense weight, but failing miserably. And finally, we must turn our attention to the deepest, darkest center of the core itself. As the absolute heaviest elements pile up like cosmic ash, the central core becomes terrifyingly compacted and impossibly dense. The internal crushing pressure multiplies, and the ambient heat climbs to unimaginable extremes. But unlike every single stage of the star's previous life, where higher heat automatically guaranteed more fusion and greater lifting pressure, this final stage operates under a completely different, fatal set of rules. This is because the absolute final, terminal byproduct of this entire chain of fusion reactions is iron. And the presence of iron changes absolutely every law of the game. The nuclear fusion of iron does not magically conjure up free, outward-pushing energy. It actively, aggressively consumes it. Therefore, the exact moment the stellar core becomes heavily saturated with iron ash, the star permanently loses its only mechanism for generating the upward pressure it needs to fight off the crush of its own gravity. And this grim reality is, without a doubt, the most profound, most terrifying warning sign of them all. It is not a visual spectacle. It is not a blinding flash of light, nor is it a violent physical tremor, but rather a quiet, fundamental breaking of the star's ability to keep itself alive. From the very moment of its birth until this exact second, nuclear fusion has operated as the star's singular weapon for holding gravity at bay. Now that weapon has been entirely neutralized, or at the very least rendered completely useless. Consequently, the immense star slips into a fatal state, where the crushing weight of gravity is no longer met with an equal and opposite force, and that grim fact completely rewrites the star's destiny. All of the hushed, subtle warning signs we have been exploring, the microscopic light fluctuations, the rhythmic physical pulsing, the invisible bleeding of energy through ghost particles, have all been marching steadily toward this exact terminal moment. It is the precise moment where the grand equilibrium is no longer merely slipping or struggling. It is experiencing a total, catastrophic failure. But remarkably, even at this absolute breaking point, there is still no instantaneous, blinding explosion, no sudden, violent eruption of matter into the void. The immediate consequence of this failure is not an outward blast, but something entirely different, something moving inward, and something moving with terrifying, unbelievable velocity. Because the instant the central core realizes it can no longer shoulder the burden of its own immense weight, the force of gravity does not pause for deliberation. It attacks, and when gravity finally makes its ultimate move, the slow, agonizing mutations that have been brewing for eons are instantly replaced by a reaction that is violently, shockingly abrupt. It is a reaction that does not play out over the course of millions of years, nor does it take days to execute, but rather it is finalized within a literal fraction of a single heartbeat. Throughout the entirety of its life up to this point, whenever the star felt itself slipping out of balance, it miraculously discovered a way to right the ship. The fusion engine would momentarily sputter, gravity would subsequently squeeze the core tighter, the heat would instantly skyrocket, and the fusion engine would happily roar back to life. It was an incredibly trustworthy, unbreakable cycle, one that effectively granted the star the gift of stability for the vast majority of its existence. However, that entire self-rescue mechanism relies heavily on one absolutely non-negotiable requirement. The process of nuclear fusion must actually possess the ability to respond to the squeeze, and in this terminal moment, it simply cannot. Buried deep within the pitch-black center of the core, The chemical recipe has reached a terminal state where the standard laws of stellar physics have been completely thrown out the window. The massive accumulation of brutally heavy elements, most notably the towering pile of iron ash, has silently robbed the star of its absolute last, desperate source of outward-pushing strength. Nuclear fusion, the grand, fiery counterweight that has valiantly wrestled with gravity since the dawn of the star, is officially permanently retired from active duty. Therefore, when the unrelenting weight of gravity begins to bear down and squeeze inward, there is absolutely zero retaliatory force pushing back up against it. And this is the exact terrifying juncture where the entire narrative shifts into something profoundly different. It is not a visually dramatic moment at first, nor is it a fiery explosion, but it is deeply, undeniably final. The force of gravity officially wins the war. It is not a sudden, violent conquering in the sense of a single, chaotic flash. It is much better described as a heavy, irreversible tipping point that the star has been inching toward for millions of years. And once that line is crossed, every single atom in the core begins to hurl in only one possible direction: straight down. The core, which has already been shrinking through microscopic, reluctant adjustments over the eons, now initiates a plunge that is brutally, catastrophically serious. The internal crushing pressure multiplies at a terrifying, almost vertical rate. The physical density of the matter sky rockets off the charts. Physical matter is violently crammed tighter and tighter together into an impossibly small, claustrophobic space. And because aggressive physical compression always births intense heat, the dying core becomes exponentially, hellishly hotter. But this time around, that massive spike in temperature fails to trigger any kind of rescuing or stabilizing effect. There is no hidden, secret stage of nuclear fusion waiting in the wings to throw the star a life preserver. There is absolutely no auxiliary mechanism that can suddenly spark to life and conjure up enough raw energy to combat the terrifying inward crush. Instead, that newly generated skyrocketing heat actively fuels a nightmare sequence of physical reactions that actually makes the star's grim situation significantly worse. One of the absolute first devastating consequences is a bizarre phenomenon known to physicists as photodisintegration. Under these nightmarish, extreme temperature spikes, the localized photons, which are essentially tiny packets of pure light bouncing around the core, become so wildly energetic that they possess the sheer physical force to literally shatter atomic nuclei. The heavy iron nuclei, which the star painstakingly spent the last few days desperately building up, begin to violently crack apart into vastly smaller, useless fragments. While this might seem like a trivial, highly technical footnote, it carries a shockingly devastating consequence for the dying star. The physical act of shattering those heavy nuclei actively sponges up raw energy from the surrounding environment. So rather than generating the desperate outward pressure the star so badly needs, the crumbling core is now bleeding its remaining energy reserves at an even faster and catastrophic pace. It is directly comparable to a person desperately trying to keep a heavy roof from caving in, while simultaneously watching their only supporting pillars not only buckle, but actively begin to drain the remaining strength from their own arms. Simultaneously, a second, equally devastating physical process begins to run rampant within the darkness of the core. As the sheer physical density of the space skyrockets, tiny, negatively charged electrons are aggressively, forcibly shoved closer and closer to the atomic nuclei. In a normal, healthy environment, electrons happily orbit their nuclei at a very comfortable, respectful distance. But within this nightmarish, claustrophobic pressure cooker, the luxury of empty space has been entirely eliminated. The electrons are brutally, physically rammed straight into the positively charged protons, and when that violent collision occurs, they instantly meld together to forge neutral particles known as neutrons. This specific, violent process is officially labeled electron capture, and it introduces two incredibly destructive side effects to the dying star. First, it instantly wipes out a massive portion of the available electrons, that were desperately trying to provide a stabilizing force known as electron degeneracy pressure. This pressure was one of the absolute last remaining physical barriers trying to fight off the terrifying crush of gravity in this hyperdense environment. As those vital electrons continually vanish by merging into protons, that final, desperate source of structural resistance completely evaporates. Second, this violent merging process births staggering swarms of those ghostly particles we discussed earlier, neutrinos. And as we previously established, those ghostly neutrinos possess the ability to instantly phase out of the core, carrying massive amounts of precious energy away with them as they flee into the void. So as of right now, the crumbling core is violently hemorrhaging its life-saving energy through multiple, unstoppable avenues. The shattering of the iron nuclei is actively devouring energy. The fleeing swarms of ghost particles are physically stealing energy and dumping it into space. The disabled fusion engine is no longer capable of contributing a single drop of replacement energy to the cores, and gravity, completely unchecked and unopposed, continues to drag every single atom violently inward. At this specific, terrifying juncture, the physical condition of the star has completely abandoned any recognizable definition of stability. The deepest center of the star is in a state of absolute catastrophic free fall. It is not a slow, reluctant shrinking, nor is it the gentle settling it experienced in the past, but rather a blindingly rapid, violent plunge. The entire concept of time mutates drastically right here. Physical changes that previously demanded millions of years to execute are now violently resolving themselves in literal seconds. The physical radius of the star's core violently implodes at a speed that defies all rational comprehension. Physical material that formerly occupied a sprawling, vast expanse of space is brutally smashed into a shockingly microscopic volume. The resulting physical density reaches a level of extreme absurdity, pushing far past any parameter we could ever encounter in our daily lives on Earth. To truly wrap your head around the severity of it, try to visualize taking the entire physical bulk of our massive sun and violently squashing it down into a tight little sphere measuring perhaps 20 or 30 miles across. That is the exact flavor of hellish density we are currently dealing with, and as the core violently caves in on itself, the actual velocity of the plummeting, inward-falling matter ramps up exponentially. The terrifying force of gravity steps on the accelerator, dragging absolutely everything toward the pitch-black center faster and faster. There is absolutely zero balance left in this equation. No give and take between opposing cosmic forces. It has devolved into a horrifying, one-way ticket straight into the abyss, inward, hurtling faster and faster and faster. And yet, astonishingly, even in the midst of this chaotic, blinding freefall, there is still a grim architectural structure to the nightmare. The vast, outer atmospheric layers of the doomed star are not actually plummeting at the exact same terrifying speed as the deep core. They are technically remaining completely ignorant of the chaos below for a brief moment, still temporarily propped up by the failing pressures, hovering just above the plunging center. So, for a genuinely surreal, incredibly brief fraction of time, you have a bizarre physical scenario where the deep heart of the star is collapsing at near light speed, while the massive outer shell remains blissfully, perfectly frozen in place. It is a stark, terrifying division of physical reality. The absolute center of the star is screaming downward into oblivion, while the remainder of the massive sphere hasn't even received the memo that the end has arrived. But that eerie, frozen delay is destined to be short-lived, because the violently plunging core is rapidly churning up conditions that will violently rewrite the destiny of the entire star. The sheer physical density at the absolute center of the free fall continues to skyrocket without mercy. The crushed particles are shoved so aggressively against one another that they eventually hit a brutal, unyielding physical limit where they simply cannot be squeezed any tighter using conventional physics. This is the exact moment where an entirely new, incredibly stubborn physical law enters the arena. It is a phenomenon known as neutron degeneracy pressure. In much the same way that electrons despise being crammed too tightly together, Newly formed neutrons possess their own quantum stubbornness when violently compressed, but this specific stubborn resistance only triggers when the physical matter is squashed to a state of absolute ridiculous hyperdensity, as the plunging core fully transforms into a solid, impenetrable ball of neutrons. This stubborn pressure violently spikes, and for a fleeting, impossible moment, it acts as an indestructible brick wall. The catastrophic, blinding collapse violently slams on the brakes. The plunge doesn't slowly decelerate. It hits a brutal, instantaneous dead end. The terrifying inward momentum of the core is violently arrested, and all of that cascading stellar material that was screaming downward at unimaginable speeds suddenly hits an immovable object. This is the definitive, split-second crossroad where the entire nature of the universe flips upside down. Because when that much unimaginable speeding mass is violently stopped dead in its tracks, all of that raw kinetic energy has absolutely nowhere else to go. So it chooses the only available exit. It explodes outward. The core violently, aggressively bounces back. This is absolutely not a soft, polite redirection of force. It is a devastating, staggeringly powerful reversal of kinetic momentum. The endless tidal wave of collapsing matter physically faceplants into the newly forged, indestructible neutron core. And the direct consequence of that cosmic car crash is the birth of an unstoppable shockwave. That nascent, violent shockwave immediately begins to tear its way outward, ripping back up through the suspended atmospheric layers of the doomed star. And this is the exact, literal second where the depressing tale of a collapsing star officially becomes the spectacular tale of a supernova explosion. But it is highly imperative that we freeze the narrative here for just a brief, contemplative moment before we chase that shockwave out into the void. Because what we have just meticulously observed is not merely a tragedy of a star simply giving up the ghost. It is a profound, mechanical sequence where the relentless force of gravity, the invisible stalker that has haunted the star since its birth, finally steps into the spotlight as the undisputed champion. For the vast, overwhelming majority of the star's biography, that crushing gravity was kept securely locked away by the heroic efforts of nuclear fusion. Then, as the fuel tank slowly ran dry, that heroic defense became increasingly ragged and difficult to maintain. And finally, with the fusion engine completely dead and unable to fight back, gravity seized total, unopposed control. It violently dragged every single atom down into the dark, crushed the core into an unrecognizable state, and flawlessly set the stage for the blinding spectacle that is about to follow. Throughout nearly the whole of a colossal star's lifespan, evolution has unfolded at a remarkably sluggish pace. Necessary internal recalibrations required millions of consecutive years to fully execute. Any precarious cosmic imbalances were smoothed out with an incredibly gentle touch. Even as the foundational stability began its eventual decline, an abundance of time remained, preserving a feeling of unhurried transition from one phase to the next. However, that leisurely cosmic tempo completely vanishes in this exact moment. Processes that formerly crawled along now accelerate to unfathomable speeds, and the entirety of this chaos is laser-focused directly upon the deepest center. Until this terrifying juncture, the stellar heart possessed the capacity to successfully fend off the crushing grip of gravity in one manner or another. Initially, it achieved this via the fiery engine of nuclear fusion, and later by employing stratified pressure zones and desperately convoluted chemical reactions. Despite the fact that those defensive strategies were rapidly deteriorating, they nevertheless managed to provide a modest buffer and a precious delay. At present, absolutely every shred of that structural resistance has been eradicated. The invisible, crushing force of gravity refuses to exercise any further patience. The very millisecond it encounters zero opposition, it strikes with immediate and ruthless intent. The central core initiates a catastrophic freefall, abandoning the measured, microscopic contractions of its past for a blindingly rapid, inward plunging acceleration. Physical material that formerly existed in a state of beautiful grace now plummets helplessly toward the abyss, violently dragged by an inescapable, overwhelming gravitational undertow. The sheer physical velocity of this inward caving is genuinely difficult for the human mind to properly visualize. We are absolutely not discussing an astronomical event that casually plays out over the course of an afternoon, or even a few tense minutes. The entire massive core is capable of violently shrinking down to a microscopic fraction of its former size, in considerably less than a single heartbeat. Stellar material is violently hurled downward at speeds approaching a significant percentage of the ultimate cosmic speed limit, the speed of light. Every single stratified atmospheric layer is yanked aggressively toward the pitch-black center with a rapidly multiplying sense of inescapable doom. This entity has officially ceased to be a functional machine capable of self-correction. It is now nothing more than a magnificent system in the throes of total catastrophic failure as the heart of the star plummets onward. The physical density of the matter spikes with terrifying sharpness. Individual atomic structures are brutally compacted against one another. The microscopic, empty voids that normally separate subatomic particles are entirely erased from existence. The comfortable, familiar architecture of physical matter completely disintegrates beneath the crushing weight of this unparalleled pressure. Tiny electrons, which previously enjoyed spacious orbits around their host nuclei, are violently rammed directly into them. Positively charged protons and negatively charged electrons forcibly merge into a single entity. This violent subatomic marriage results in the mass birth of neutral particles known as neutrons. This bizarre chemical alchemy unfolds on a staggeringly massive scale, completely transmuting the core into a substance that is entirely alien to its former self. A region that was previously defined by a bustling collection of normal atoms transforms into a hyperdense, suffocating sphere of pure neutrons. Simultaneously, as this chaotic transmutation runs its course, spectral particles called neutrinos are synthesized in genuinely unimaginable quantities. These ghostly entities instantly bleed out of the collapsing core, silently robbing the dying star of its vital remaining energy. Untold trillions of these invisible messengers slip effortlessly through the star's thick atmospheric layers and vanish into the cold void, interacting with absolutely nothing during their escape for one incredibly fleeting cosmic second. This single collapsing sphere acts as one of the most blindingly intense fountains of neutrinos in the entire known universe. Yet, buried beneath that invisible flood, the catastrophic inward plunge rages on. The central heart continues to crush itself ever smaller. The suffocating density multiplies, and the downward velocity ramps up to even more terrifying extremes. During this specific terminal phase, the catastrophic implosion actively begins to feed upon its own momentum. As the centralized gravitational pull grows exponentially stronger, the surrounding material is whipped inward at correspondingly faster speeds. The faster that stellar matter plummets, the more violent kinetic energy is unleashed through compression, subsequently driving the environmental conditions to even deeper levels of localized hell. Absolutely zero physical mechanisms remain on the board to apply the brakes to this runaway train. There are no fiery fusion engines left to push back, no sturdy pockets of internal pressure to anchor the structure, leaving nothing but the tyrannical rule of gravity. Then, without a single moment of advanced warning, the physical reality of the situation violently pivots yet again. As the crushed core achieves a state of truly impossible density, a brand new, highly exotic flavor of physical resistance suddenly joins the fray. This bizarre, unyielding quantum roadblock is formally known as neutron degeneracy pressure, in the exact same manner that tiny electrons stubbornly refuse to be packed too tightly into a confined space based on the strict rules of quantum mechanics. Neutrons harbor an identical stubborn boundary. However, this specific variety of quantum stubbornness only boots up when physical matter is tortured to the absolute most extreme densities imaginable, precisely the type of density achieved in this exact free fall. The millisecond that impossible density threshold is struck, the catastrophic inward plunge simply cannot proceed any further along its current trajectory. The terrifying, high-speed inward motion is violently, instantly terminated. Try to visualize billions of tons of matter screaming downward at unfathomable velocities, only to suddenly slam face first into a localized region that utterly refuses to yield another millimeter. The direct consequence of this cosmic traffic accident is absolutely not a gentle, polite deceleration. It is an unbelievably violent, physically devastating halt. The deepest heart of the dying star essentially crashes into an invisible brick wall at near light speed. When an object of that staggering mass is stopped that abruptly, the associated kinetic energy cannot simply vanish. It must find an alternate path. It immediately, aggressively bounces backward. The hyperdense inner core instantly petrifies into a rigid, incompressible sphere, and the endless rain of falling stellar matter violently smashes directly into its hardened surface. This unfathomable physical collision births a gargantuan high-pressure shockwave that instantly pivots and begins tearing its way back up toward the surface. This specific violent redirection of kinetic force represents the exact birth of the supernova shockwave. It sparks into existence miles deep within the star's pitch-black interior, originating precisely at the microscopic boundary line, where the catastrophic freefall met its immovable object. From that deep origin point, it begins its violent outward journey, actively fighting its way upstream against the thick atmospheric layers that are still tragically plummeting downward. During its initial inception, this surging shockwave possesses an almost incomprehensible level of raw, destructive power. It violently erupts toward the surface, dragging the unimaginable energy of the crushed core up into the blissfully unaware outer regions of the dying star. However, the mechanical reality of the situation is incredibly messy, primarily because those massive outer layers are still actively caught in the grip of their own inward freefall. Consequently, you have two staggeringly powerful, directly opposing tides, billions of tons of plasma screaming downward under the command of gravity, and a newborn shockwave desperately trying to punch its way upward against the current. This chaotic intersection of opposing forces breeds a ferociously complex, highly turbulent physical environment. As the explosive wave fights its way upward, it is forced to expend massive amounts of its own energy just to make forward progress. It is required to physically bulldoze its way through a relentless rain of falling matter, and that immense effort actively bleeds the shockwave of its initial ferocity. During the early days of astrophysical modeling, many scientists genuinely believed that this internal friction would cause the shockwave to completely stall out, resulting in a fizzled, failed detonation. Yet, in the actual mechanics of the universe, a silent, invisible ally comes to the shockwave's rescue. That unexpected, life-saving assist is provided by those very same ghostly particles we discussed earlier, the neutrinos. While the overwhelming majority of those neutrinos successfully phased out of the star without a trace, a tiny, crucial fraction of them do not immediately escape the trap. A minuscule percentage of those ghosts actually bump into the densely packed matter hovering just above the crushed core, successfully transferring a payload of raw heat into the stalled material. This sudden, invisible injection of fresh energy acts as a cosmic defibrillator, violently jolting the stalling shockwave back to life. It provides the exact, necessary surge of kinetic momentum required to push the shockwave over the hump and keep it tearing its way toward the surface. Once that explosive wave recaptures its lost momentum, it instantly transforms into an entirely unstoppable, world-ending force of nature. It brutally punches its way through the remaining stratospheres of the star, instantly flash-frying the gas, violently accelerating the matter, and finally hurling the entire structure outward in a genuinely apocalyptic detonation. However, the actual visual spectacle of that explosion, the blindingly bright light show we classify as a supernova, is still hovering just a few moments ahead in our narrative. At this precise second, we are still lingering in the exact, terrifying moment where the deep heart of the star has violently caved in and aggressively bounced back. It is a chaotic, pivotal crossroad that executes in a tiny fraction of a single second, yet it completely authors the entire destiny of the ensuing cosmic event. It represents the ultimate, violent transition from a downward plunging death spiral into a spectacular, outward bursting resurrection. It is highly worthwhile to freeze the frame here for just a moment to truly appreciate the sheer whiplash-inducing speed of this structural pivot. over a timeline spanning hundreds of millions of years, the stellar body evolved with graceful patience, constantly tweaking its own thermostat and perfectly maintaining its delicate equilibrium. Then, within a window of time too small for a human to blink, the center falls into the abyss. Standard matter is crushed into an alien state, and a world-ending shockwave is violently birthed into existence. This is definitively not a polite, leisurely stroll toward the exit. It is a brutal, instantaneous paradigm shift, a catastrophic turning point, where the complete architectural blueprint of the star is violently rewritten. From this exact millisecond forward, the narrative has officially abandoned the concept of preserving a peaceful balance. It is now entirely focused upon the chaotic, terrifying beauty of what transpires when that perfect balance is permanently shattered. The explosive shockwave resumes its violent upward journey with renewed vigor. The massive outer atmospheric layers finally begin to feel the terrifying reality of what has just occurred deep below them. Long before a single photon of light manages to break free of the surface, long before anything becomes visible across the gulf of space, an invisible defining moment has already cemented the star's fate. This hidden transitional moment does not drag on. In truth, it concludes almost the exact instant it begins. And yet, within that microscopic sliver of a second, the ultimate destiny of the glowing giant is permanently carved into stone. Up until this specific sequence, we have been tracking a magnificent system that was slowly, painfully bleeding away its own stability. The beautiful balance rotted from the inside out. Gravity seized the throne, and the core initiated its catastrophic plummet. That downward plunge snowballed with terrifying speed, squeezing physical matter to unimaginable extremes and sparking bizarre quantum reactions that stripped away the absolute last lines of defense. We have now arrived at the exact epicenter where that inward crushing motion achieves its absolute maximum level of intensity. Everything in existence within that space is hurtling directly toward the pitch-black center. Every single stratified layer of the once proud core is plunging downward at mind-bending velocities, ruthlessly yanked by a gravitational field that has finally asserted total, uncontested dominance. There is no longer a single ounce of outward pushing energy capable of fighting back against this crush. There are zero stabilizing safety nets remaining to slow this terrifying descent. It is highly crucial to recognize a fascinating irony buried within this process. Even though humanity universally visualizes these events as stars violently blowing themselves apart, the actual, defining spark is the exact physical opposite. It is a profound, catastrophic implosion. The dying star does not commence its phenomenon by bursting outward into the void. It begins its death throes by caving inward at a speed that vastly eclipses any other movement it has ever experienced in its entire billion-year lifespan. Furthermore, this catastrophic inward caving is absolutely not a perfectly smooth, uniform occurrence. The absolute dead center of the core, the deepest, most heavily compressed region, begins to behave according to wildly different physical rules than the material surrounding it. As the suffocating density reaches a boiling point, that inner sanctuary hits a threshold where it physically petrifies, transforming into a bizarre neutron-heavy substance that flatly refuses to be squeezed any tighter. However, just a few miles above that petrified inner core, billions of tons of stellar material are still screaming downward in a state of uninhibited free fall. Consequently, you are left with an incredibly violent mismatch of physics where the deepest center is violently slamming on the brakes, while the outer core is still aggressively stomping on the accelerator. This profound physical discrepancy breeds an unbelievable amount of structural tension, a terrifying mechanical mismatch of kinetic energy. The endless rain of plummeting stellar material does not politely flutter down onto the surface of this newly hardened core. It smashes into it with the force of 1 trillion sledgehammers. During this specific phase, the speeds are so unbelievably fast and the physical densities are so punishingly extreme that this cosmic collision defies any comparison to earthly physics. It is far more akin to forcing an ocean of physical matter into a microscopic thimble that physically lacks the geometry to contain it. The hardened inner core stubbornly holds its ground, The plunging outer layers refuse to stop their advance, and within that blindingly violent fraction of a second, the implosion achieves its absolute terrifying peak. This is the genuine, undisputed climax of the implosion. It is the exact geographical and temporal coordinate where the inward crushing momentum has traveled as far as the laws of physics will permit. The central core physically cannot be squashed another inch. The bizarre, quantum mechanical rules of neutron degeneracy pressure, acting in concert with the strongest nuclear forces in the universe, have erected an indestructible hard limit. If you attempt to push past this specific boundary, the fundamental rules of reality begin to break down entirely. Therefore, when the screaming avalanche of infalling matter violently strikes this invisible boundary line, it absolutely does not continue its journey downward. It is halted with unimaginable, spine-shattering violence, and that sudden, brutal termination of movement is the most crucial key to this entire puzzle, because everything that was hurtling downward at near light speed now has absolutely nowhere left to travel. Physical momentum is not something that can simply be erased from the universe. Raw kinetic energy cannot magically evaporate into thin air. Instead, it must be violently, instantaneously redirected. In that exact blinding instant, a catastrophic implosion aggressively metamorphoses into something entirely new. The hardened core, having successfully defended itself against further crushing, behaves almost identically to a solid, concrete floor. The cascading avalanche of collapsing matter violently smacks into it, and the unfathomable kinetic energy of that collision is instantly transmuted into raw, explosive pressure. That pressure spikes with terrifying speed, and then it violently unleashes itself in the opposite direction. This aggressive reversal of fortune happens with genuinely unbelievable swiftness. There is absolutely no dramatic, prolonged silence lingering between the crushing collapse and the explosive rebound. In one fleeting heartbeat, an entire star is screaming inward toward its own center. In the very next heartbeat, a world-ending shockwave is already forming, violently clawing its way back up toward the heavens. But lingering precisely at the razor-thin boundary separating those two distinct actions, there is a microscopic, almost invisible sliver of time where every atom in the core is squeezed to its absolute breaking point. The physical density is completely off the charts. The localized temperature is so insanely high it defies human vocabulary, and the environmental conditions are more alien than anything else found in the known universe, with the possible exception of other neutron stars or the hearts of black holes. It is genuinely taxing for the human brain to properly conceptualize what this environment actually looks like. Physical matter, in the comfortable way we interact with it on Earth, has completely ceased to exist or behave in any recognizable fashion. Standard atoms have been violently dismantled and stripped for parts. Naked atomic nuclei are jammed shoulder to shoulder in a suffocating embrace. The very concept of distinct individual particles loses all meaning when faced with such an overwhelming, crushing density. In a deeply poetic sense, it is the absolute most compact, compressed physical state the dying star can possibly endure, without accidentally plunging into something even more terrifying and permanent. And then, almost as rapidly as it achieved that impossible state of density, the physical reality begins to violently shift yet again. The explosive, outward-facing rebound officially begins. Now, an entirely separate, equally crucial phenomenon is occurring simultaneously. Throughout the entirety of this catastrophic cave-in, those ghostly neutrinos have been continuously birthed in genuinely mind-boggling numbers. These spectral particles, forged in the fires of electrons violently merging with protons, silently carry massive amounts of energy away from the dying core. The vast majority of them simply slip away into the dark, phasing effortlessly through the exploding star with almost zero physical interaction. But that rule does not apply to every single one. A tiny yet vital fraction of these ghostly messengers actively collides with the dense wall of matter hovering just above the newly hardened core, violently dumping their stolen energy into it. This specific invisible energy transfer becomes incredibly vital in the chaotic milliseconds immediately following the implosion, as it actively injects fresh power into the struggling, outward-bound shockwave. Therefore, while the implosion itself represents a terrifying moment of inward free fall slamming into a brick wall. It is also the grand architectural setup for every spectacular event that is about to follow. It perfectly dictates the exact starting conditions required for a genuine cosmic explosion. It mathematically decides exactly how much explosive energy will be brought to bear. It physically sculpts the shape and density of the bizarre core that will be left behind in the ashes. And it perfectly sets the stage for the violent, outward-facing eruption that will shortly dominate the sky. Viewed from the safety of a distant planet, absolutely none of this terrifying internal drama is currently visible. There is no brilliant flash of illumination, no sudden, blinding brightening of an otherwise peaceful nighttime canopy. Every single ounce of this world-ending violence is unfolding miles deep within the belly of the star, completely smothered beneath thousands of miles of gas that remain entirely ignorant of the chaos below. But the grand, irreversible transformation is already fully in motion. The celestial giant, which has diligently spent millions of consecutive years preserving its flawless structure, has now suffered a completely permanent, foundational paradigm shift. Its deep heart has caved in, smashed into a physical wall, and aggressively bounced backward. And in executing that violent sequence, it has successfully manufactured the exact conditions necessary to birth one of the most terrifyingly energetic spectacles in the entire cosmos. It is highly worthwhile to reflect upon just how stunningly abrupt this grand transition truly is. For a timeline spanning millions of unhurried years, the stellar body mutated at a glacial, lazy pace. Then, in a window of time occupying less than a single second, the entire core catastrophically imploded and violently rebounded. Now, in the chaotic, frantic moments that are currently unfolding, the true explosion begins to tear its way toward the surface, violently hurling the star's guts outward into the cold void. But even though we have officially reached the point where we can accurately label this a cosmic explosion, we still do not possess the complete final picture. The destructive shockwave has only just commenced its violent upward ascent. It still possesses a long, brutal journey through the remaining layers of the dying star. It still has a massive distance to cover before it successfully punches through the outer surface. Unlike every single gentle, unhurried evolutionary phase that preceded this moment, there is absolutely zero patience remaining in this doomed system. For the vast majority of its long existence, the glowing sphere tweaked its internal thermostat with remarkable, sluggish grace. Even when the creeping shadows of instability first began to take root, the resulting structural mutations were highly measured, heavily stratified, and almost delicate in the manner they slowly blossomed. But the exact second that violent rebound occurred and the explosive shockwave was formally birthed, that long, ancient history of unhurried evolution was instantly tossed into the incinerator. Now, absolutely everything is moving with terrifying, blinding speed. The newborn shockwave that sparked to life deep within the crushed core does not politely wait for instructions. It does not pause for a moment of reflection to stabilize its energy or thoughtfully reorganize its trajectory. It violently erupts upward immediately, hurtling the incomprehensible energy generated by the collapse and the subsequent bounce straight toward the heavens, aggressively slamming into regions of the star that, mere milliseconds ago, had absolutely no inkling that a catastrophe was unfolding. And that stark, violent contrast is incredibly important to understand. Because while the deep center has already endured a complete, world-ending transmutation, the massive outer atmospheric layers are technically still living completely in the past. They are still peacefully holding the exact same architectural shape they possessed long before the deadly collapse ever began, still stubbornly clinging to the ancient physical forces that kept the star alive for millions of years. For a remarkably brief, almost surreal window of time, a massive physical disconnect exists. The deepest heart of the star has been completely rewritten into an alien state. The outer skin remains completely, blissfully untouched. The violently ascending shockwave is the sole entity responsible for bridging that massive, bizarre gap in reality. As it tears its way upward toward the surface, it functions as a brutal, high-speed messenger delivering catastrophic news that simply cannot be ignored or bargained with. It aggressively crushes the thick stellar gas lingering directly in its path, instantly flash heating it, violently speeding it up, and ruthlessly forcing it to endure environmental conditions that are exponentially more severe than anything it has ever encountered. And it executes this violent restructuring at a speed that defies human comprehension. While it may not travel at the literal speed of light, it still moves with such staggering, terrifying urgency that, relative to the massive scale of the star, it crosses distances in the blink of an eye. Thick atmospheric layers that previously required thousands of leisurely years to slightly evolve are now being violently pulverized and reshaped in a matter of seconds. The rising shock wave is absolutely not a gentle rolling ocean swell. It is a hard, violent, destructive boundary line separating two completely different states of physical reality. Trailing directly behind it, the stellar material has been violently superheated, heavily energized, and forcefully blasted into an outward expanding trajectory. Looming directly ahead of it, the stellar material remains entirely trapped in its original peaceful state, or in many bizarre cases, is actually still tragically plummeting downward toward the core. Therefore, as the explosive shockwave relentlessly advances, it carves a razor-sharp, hyper-violent line of transition through the star's interior. Absolutely everything it comes into physical contact with is instantly, permanently altered. The thick atmospheric gas it bulldozes through is aggressively compressed into states of significantly higher density. The localized temperature of that gas instantly skyrockets to unimaginable extremes. Standard atoms are violently stripped naked, losing their electrons and instantly transforming into highly ionized plasma. In certain specific, hyper-compressed pockets, the sudden violent spike in heat and pressure is actually enough to spontaneously trigger brand new nuclear fusion reactions, hastily forging completely new heavy elements within the absolute chaos of the explosion itself. Every single one of these violent transmutations executes in a fraction of an instant, and yet, the ascending shockwave is not entirely immune to the brutal physics of the environment it is attempting to conquer. As it aggressively tears its way outward toward the surface, it must constantly wage war against the stubborn physical inertia of the massive gas layers lingering directly in its path. That floating stellar material possesses a staggering amount of physical mass, and forcefully relocating that mass demands a terrifying expenditure of raw energy. Consequently, with every single atmospheric layer the shockwave successfully punches through, it bleeds away a noticeable fraction of its own destructive strength. This is unequivocally not a simple, frictionless, unopposed expansion into empty space. It is a brutal, uphill street fight against gravity and mass. The explosive shockwave violently shoves upward. The surrounding massive blanket of stellar material stubbornly pushes back. Raw energy is violently transferred, but it is simultaneously scattered and diluted in the chaos. And for a genuinely tense, terrifying stretch of time, it is not entirely certain which of these two competing forces will ultimately emerge victorious. Earlier in this narrative, we briefly touched upon the haunting possibility that the rising shockwave might actually stall out and fail. This is the precise, agonizing stage of the explosion where that theoretical possibility morphs into a very genuine, looming threat. As it aggressively fights its way closer to the surface, the explosive wave begins to noticeably decelerate. The staggering payload of energy it currently carries is actively being spread too thin, desperately utilized to superheat and violently displace the star's impossibly heavy outer blankets. Without an immediate, massive injection of auxiliary support, it could very easily bleed off the last of its momentum and die. But this is precisely the moment where the bizarre, hidden physics operating down near the crushed core continue to silently influence the battle above. Even as the struggling shockwave aggressively climbs toward the surface, those ghostly neutrinos are still being mass-produced and are still silently fleeing from the hyperdense core. And a small yet critical fraction of those fleeing ghosts successfully ram into the super-dense material lingering immediately behind the ascending shockwave, violently dumping a massive payload of fresh heat directly into it. That sudden, invisible injection of heat acts acts as a massive, much-needed cosmic reinforcement. It physically fortifies the superheated region trailing the shockwave, providing the exact, necessary burst of extra-kinetic muscle required to keep the wave tearing its way toward the surface. Therefore, rather than suffering a slow, fizzling death, the explosive shockwave successfully recaptures its lost momentum. It instantly becomes exponentially more effective, vastly more capable of violently bulldozing its way through the final remaining stratospheres of the doomed star. And as it successfully accomplishes this, the entire foundational architecture of the star begins to violently, permanently unravel. The thick, heavy outer layers, which previously rested in a perfectly comfortable, highly stable configuration for eons, are now being violently hoisted upward and blasted out into the void at terrifying velocities. The ancient, ironclad gravitational grip that successfully anchored them in place for millions of years is currently being violently overpowered by the sheer, unadulterated energy of the shockwave. This violent outward expansion is absolutely not a perfectly smooth, symmetrical, or uniform motion. Different atmospheric layers react to the explosive wave in highly unique, slightly chaotic ways. Certain pockets of gas are blasted outward with terrifying swiftness, while heavier, more stubborn pockets momentarily lag behind the surge. The ultimate consequence of this mismatch is a deeply complex, highly turbulent web of motion, featuring massive chunks of stellar guts hurtling outward into the dark at wildly varying speeds. If you somehow possessed the magical ability to observe this catastrophic process from a front row seat, it would absolutely not resemble a perfectly smooth, flawless balloon inflating symmetrically in all directions. It would appear as a violent, turbulent, heavily chaotic storm, brimming with aggressive motion and violent physical collisions. But when viewed from a vast, safe distance, the overarching, big-picture effect is undeniably clear. The magnificent star is violently, irrevocably tearing itself into pieces, and as the explosive shockwave stubbornly continues its relentless upward journey, it finally begins to encroach upon the absolute outermost, thinnest layers of the star's atmosphere. These final wispy layers are significantly less dense than the crushing heavy regions located near the core, which instantly alters how the shockwave behaves. Encountering vastly reduced physical resistance, the explosive wave is suddenly capable of accelerating once again, moving with terrifying unrestricted freedom as it rapidly closes the distance to the surface. And this is the exact, breathtaking precipice where the narrative transitions from a hidden, subterranean catastrophe into a spectacularly visible cosmic phenomenon. Up until this exact millisecond, absolutely every single violent act has been playing out deep beneath the glowing skin, entirely obscured from the eyes of the universe. But as the ascending shockwave finally breaks through to the outer layers, it begins to aggressively dump its payload of energy into regions that are perfectly capable of radiating that heat directly into the blackness of space. Those final, outermost atmospheric layers heat up with genuinely blistering, unimaginable speed. Their overall luminous output skyrockets on an exponential curve, and when that violent shockwave finally shatters the absolute outer boundary of the star's surface, the staggering ocean of energy it has been ferrying from the core is violently vomited outward in a blinding display that can easily be witnessed from across the most unimaginable gulfs of space. Even before that brilliant optical flash graces the cosmos, the internal architecture of the star has already been irreversibly scrambled. The elegant, meticulously layered anatomy that the star painstakingly constructed over millions of years has been entirely obliterated. The rigid boundaries separating the distinct fusion zones are violently erased as superheated material is aggressively churned and blasted outward. Exotic, heavy elements that were once permanently imprisoned within the crushing depths of the core are now being violently dredged up toward the surface. This chaotic internal blending carries profound cosmic consequences, as it allows the deeply forged products of the star's lifelong labor to be widely dispersed. These precious elements are thoroughly mixed into the churning debris of the explosion, preparing them for their eventual journey into the interstellar void. However, the ultimate fate of those scattered elements is a chapter we will explore a little further down the path. For the time being, our primary focus must remain anchored on the sheer, unstoppable momentum of the event. The catastrophic shockwave is still aggressively traveling, still violently expanding, and still ruthlessly reshaping absolutely everything it touches. With every single atmospheric layer it successfully breaches, the stellar body is dragged further and further away from its former identity. It has definitively ceased to be a balanced, harmonious, and stable celestial object. It is now nothing more than a rapidly expanding cloud of chaotic debris, relentlessly propelled by the staggering energy released during a singular, catastrophic implosion. From a vast, interstellar distance, the universe offers absolutely zero advanced warning of the impending spectacle. There is no gentle, gradual increase in luminosity to hint at the world-ending events that have already transpired deep within. One moment, the star appears perfectly ordinary, blending seamlessly into the tranquil tapestry of countless other distant suns. And then, in a sudden, breathtaking instant, its appearance fundamentally transforms. It brightens with an intensity that is not merely a subtle fluctuation, but a dramatic, undeniable surge that demands the attention of the entire cosmos. It flares with such staggering ferocity that it can easily rival, and sometimes completely outshine, the combined light of billions of other stars residing within its host galaxy. That is the precise, defining moment when the hidden, subterranean nightmare finally broadcasts itself to the wider universe. As the explosive wave violently breaks through the outer atmospheric shell, it drags the suffocating heat of the collapsed core directly to the surface. The outermost gases are instantaneously flash-fried to temperatures that defy human comprehension, causing them to radiate light with a genuinely blinding intensity. Astrophysicists frequently refer to this specific visual milestone as shock breakout. It is the exact fleeting window of time where the unfathomable energy that had been violently trapped inside the star is finally allowed to bleed into the vacuum of space. Within a shockingly brief period, the apparent brightness of the dying star multiplies by an astronomical factor. A celestial body that might have previously been completely invisible to distant observers suddenly commands the night sky as one of the most brilliant objects in existence. This phenomenal brightness is absolutely not a consequence of the star miraculously growing larger or adding new mass. It is entirely the result of an incomprehensible volume of stored energy being violently dumped into the universe all at once. It is highly beneficial to pause and reflect on this brilliance, because this blinding light is not actually the physical explosion itself. It is merely the visual echo, the radiant aftermath of the mechanical processes that have already successfully concluded. The deepest core has already suffered its catastrophic collapse. The violent physical rebound has already birthed the world-ending shockwave. That destructive wave has already successfully completed its brutal journey through the star's interior. What we are currently witnessing is simply the grand finale, the outer layers desperately attempting to radiate that transferred energy as they are violently blown apart. Furthermore, this spectacular light show does not simply blink into existence and immediately vanish. Following the initial blinding shock breakout, the luminosity of the expanding debris cloud continues to evolve and shift. The shredded outer layers of the star are still actively expanding, hurtling outward into the dark at terrifying supersonic speeds. As this chaotic material spreads thinner and thinner across the void, it naturally begins to cool down. Yet it stubbornly continues to radiate intense energy. The visible brightness slowly climbs to an absolute peak, lingering there for a time before embarking on a long, graceful decline, depending entirely on the specific mechanical details of the original star. This gradual fading process can easily stretch across days, weeks, or occasionally even several months. Therefore, a true supernova is never just a rapid, momentary flash in the pan. It is a sustained, highly energetic cosmic event, a fiercely glowing, evolving beacon that can be meticulously studied from the opposite side of the universe. While this brilliant light show captivates external observers, something equally profound is occurring within the expanding guts of the star itself. The sheer violence of the explosion has successfully manufactured entirely new exotic elements. During the star's peaceful life, the gentle fusion engine was only capable of forging elements up to the atomic weight of iron. But the chaotic, hyper-pressurized environment of the explosion itself is vastly more extreme than anything the living star could ever produce. The ambient temperatures and crushing pressures spike high enough to spontaneously trigger incredibly rare nuclear reactions. Heavy, precious elements that simply cannot be synthesized under normal, stable stellar conditions are suddenly forged in the blink of an eye. Beautiful materials like gold, silver, and uranium are violently birthed directly inside the chaotic inferno of the expanding dim. These newly minted heavy elements are seamlessly woven into the expanding cloud, hitching a ride outward as the star's remnants spread into the cosmos. However, from the grounded perspective of a human observer peering up at the night sky, what truly commands the imagination is the sheer sudden arrival of that light. Throughout the vast, unwritten chapters of human history, this specific cosmic phenomenon has been witnessed and recorded on numerous occasions. Ancient astronomers would gaze upward and marvel at a brilliant, piercing new point of light that had seemingly materialized out of nowhere. They poetically referred to these cosmic anomalies as guest stars, noting their sudden arrival, their temporary residence in the sky, and their eventual quiet departure. They were entirely unaware that they were actually witnessing the violent death throes of a supermassive celestial giant. One of the most legendary and meticulously documented examples graced our skies in the year 1054, blooming brightly within the constellation of Taurus. This particular explosion was so incredibly radiant that it remained clearly visible in the broad daylight for several consecutive weeks. The haunting, sprawling cloud of expanding gas that was left behind by that specific event is known today as the Crab Nebula. Even now, nearly a full millennium later, that glowing nebula still carries the unmistakable physical fingerprints of that ancient, violent explosion. But for the bewildered humans observing it all those centuries ago, it was nothing more than a sudden, beautiful, and completely unexplained new companion in the heavens. That beautiful, sudden manifestation remains one of the absolute defining hallmarks of a true supernova, despite the fact that the invisible internal decay required millions of years to reach a critical threshold. The ultimate visual payoff arrives with shocking immediacy. Now, it is deeply important to recognize that this resulting burst of light is not perfectly uniform across every single event in the cosmos. Different varieties of supernovas can achieve wildly different levels of peak brightness, entirely dependent upon the mass of the progenitor star and the exact physics of the detonation. Some of these cosmic explosions burn with a much fiercer intensity than others. Some of them fade into the blackness with surprising speed, while others linger for months with highly complex, fluctuating light curves. Yet the foundational narrative arc remains beautifully consistent across the board. There is always a rapid, undeniably violent spike in luminosity, followed by a brilliant peak, and finally, a slow, mournful fade back into obscurity. And throughout the entirety of that long, slow decline, the violently expanding cloud of stellar material continues to dilute itself into the interstellar void. The original star has completely surrendered its status as a singular, cohesive physical object. It has been permanently transformed into a sprawling, chaotic nebula of superheated gas and freshly forged elements, traveling outward at genuinely terrifying velocities. And buried deep within the absolute center of that expanding cloud, the mangled, crushed remnant of the original core silently remains. Depending entirely upon the initial starting mass of the star, that crushed heart has either petrified into a hyperdense neutron star, or it has completely collapsed out of our physical reality to become a black hole. But from our distant, earthbound vantage point, the first and most captivating chapter of the story will always be the light. That sudden, piercing brightness serves as an undeniable cosmic distress beacon. It is a brilliant signal broadcasting the fact that something of monumental significance has just concluded, and that a star has officially reached the terminus of its long journey. It loudly proclaims that an incomprehensible sum of energy has been unleashed, and that a massive payload of stellar material has been forcefully evicted into the surrounding space. So when astrophysicists casually mention that a single supernova can outshine an entire galaxy, they are specifically referring to this exact fleeting window of time. It is the singular moment when millions of years of patiently hoarded energy are violently liberated in a display that effortlessly crosses the deepest voids of the universe. It is a staggeringly brief event when compared to the agonizingly long lifespan of the star itself. Yet it is undeniably one of the most powerful occurrences in nature. And even as that brilliant light slowly disperses and fades from our vision, the physical story of the star continues to unfold. A sprawling, expanding cloud of stellar debris is still actively traveling, still violently colliding with the surrounding interstellar environment. It acts as a cosmic delivery mechanism, carrying the heavy elements synthesized during the star's life directly into the empty regions of the galaxy. As this massive gaseous remnant continues to spread and thin out, it begins to sculpt entirely new complex structures in the dark. These ghostly, glowing shapes can be observed by modern telescopes thousands of years after the original explosion has vanished from the naked eye. Therefore, while the blinding flash of light serves as the official announcement of the star's death, it is absolutely not the conclusion of the process. It is merely the first, undeniable clue that the celestial body has completely abandoned its stable existence to become something vastly more chaotic and beautiful. If you happen to step outside on a deeply quiet night and gaze upward, the sky generally projects an aura of absolute, comforting permanence. You see the exact same familiar constellations, the same dependable points of light, and you naturally assume that everything suspended up there is distant, serene, and perfectly unchanging. But I invite you to imagine, just for a fleeting moment, that this comforting illusion of permanence is suddenly broken. Imagine looking toward a completely ordinary patch of the night sky that you have casually observed 100 times before, and right there, occupying a space where absolutely nothing of interest previously existed, a brilliant, piercing new star is proudly shining. At first, your logical brain might attempt to dismiss it as a wandering planet, a high-altitude aircraft, or perhaps a trick of the atmosphere. But this mysterious new light refuses to drift or blink like an earthly object. It remains perfectly anchored among the ancient constellations, burning with an undeniable clarity. This is exactly what the breathtaking appearance of a relatively nearby supernova would look like from the surface of our world. You would absolutely not witness a fiery, expanding fireball or a cinematic explosion unfolding in real time. The astronomical distances involved are simply far too vast for the human eye to perceive any physical sense of expanding motion or billowing gas. Instead, your entire experience would be distilled down to the sudden, silent manifestation of a brilliant point of light, a star that was previously entirely invisible, or perhaps so hopelessly dim that no human ever bothered to log its existence, is suddenly dominating that specific quadrant of the sky. The exact level of that visible brightness would depend entirely upon the star's geographical distance from our own solar system. If this catastrophic detonation unfolded in a neighboring galaxy millions of light years away, it would likely remain completely invisible to your naked eye, appearing only as a tiny smudge on a professional telescope's imaging sensor. But if that massive star happened to reside within the borders of our own Milky Way galaxy, the visual experience would be profoundly different and deeply mesmerizing. A supernova detonating relatively close to our cosmic neighborhood could easily burn bright enough to cast distinct, eerie shadows on the ground during the dead of night. In incredibly rare, extreme historical cases, these exploding stars have burned with such ferocity that they were clearly visible in the sky alongside the midday sun. The ancient humans who meticulously recorded those daylight anomalies possessed absolutely no modern scientific framework to explain what they were looking at. They only knew, with absolute certainty, that the supposedly eternal, unchanging heavens had suddenly, violently altered their pattern. From the comforting safety of Earth, observing this phenomenon would feel remarkably peaceful, completely divorced from the world-ending violence actually occurring at the source. You would watch the new star slowly gather its strength over the course of several days, eventually reaching a magnificent glowing peak. For a brief It would act as a constant, brilliant companion in the night, drawing the awe and curiosity of anyone who bothered to look up. Then, with agonizing slowness, that brilliant new companion would begin to gently fade away. The dimming process would be incredibly subtle, barely noticeable from one evening to the next, but over the span of several weeks, the decline would become undeniable. Eventually, the star would exhaust its radiant energy and completely fade back into the comforting obscurity of the black sky. Yet for the professional astronomers aiming their instruments at that fading light, the visual dimming is merely the opening chapter of the investigation. By capturing the remaining light and carefully refracting it into a detailed spectrum, they can decipher the exact chemical fingerprints hidden within the explosion. They can accurately determine exactly what specific elements were forged in the blast, how violently the gaseous debris is expanding, and what exact variety of star originally triggered the event. But for the casual, backyard observer simply enjoying the quiet of the night, the experience remains beautifully uncomplicated. A brilliant new light silently arrives. It proudly shines for a season, and then it gracefully bows out. There is a deeply poetic, almost melancholic beauty tucked away inside of that simple human experience, while the internal physics dictating the explosion are terrifyingly complex and unbelievably violent. The visual result we actually witness is nothing but a silent, fading glow. Furthermore, there is a mind-bending concept regarding the timing of this event that we must always keep in the forefront of our thoughts. When we observe the sudden brightening of a supernova from Earth, we are absolutely not watching the event unfold in the present moment. Because the speed of light is a finite, measurable limit, the illumination from that distant explosion requires an enormous amount of time to physically cross the void and reach our eyes. If a star violently detonates 10,000 light years away from our planet, the visual evidence of that death takes exactly 10,000 years to arrive on our doorstep. Therefore, by the time we finally see the brilliant flash in our night sky, the actual physical explosion has been over and done with for millennia. We are literally peering deep into the ancient past, witnessing a historical snapshot of a catastrophe that concluded long before human civilization even existed. This undeniable physical reality adds a deeply profound, almost ghostly layer to the entire experience of stargazing. You are not merely observing a distant geographical location. You are physically looking backward through the tunnel of time. And yet, because that ancient light is only just now splashing against your retinas, the experience feels incredibly immediate and deeply personal. Let us take a moment to imagine a purely hypothetical scenario where a massive star detonates in uncomfortably close proximity to our own solar system. While this is a statistically rare occurrence, it is a fascinating thought experiment regarding the sheer scale of the energy involved. If the dying star were close enough, the resulting flood of high-energy radiation, specifically X-rays and gamma rays, could easily strip away massive portions of Earth's protective ozone layer. This would not be a Hollywood-style, instantaneous incineration of the planet, but rather a slow, creeping ecological disaster as harmful ultraviolet light from our own sun flooded the surface. Additionally, the expanding shockwave from the supernova would eventually hurl a barrage of highly energized subatomic particles, known as cosmic rays, directly through our solar system. These accelerated particles could trigger chaotic mutations within our atmosphere and actively disrupt the fragile biological ecosystems clinging to the surface. However, the comforting reality of our universe is that space is almost incomprehensibly vast, and that sheer, unimaginable distance acts as the ultimate cosmic shield. The absolute closest known candidates for a future supernova are located at such a comfortable extreme distance that their eventual detonations will pose absolutely zero threat to our beautiful blue world. We will simply be treated to a magnificent, harmless light show in the night sky, a spectacular reminder of the violent, beautiful physics operating far beyond our reach. And that brings us perfectly back to the most comforting, grounding thought of this entire cosmic journey. Despite the incomprehensible violence, the crushing gravity, and the world-ending shockwaves, the ultimate result of a supernova is fundamentally an act of creation. The heavy, precious elements that were violently forged in the belly of the explosion, the iron in your blood, the calcium in your bones, the gold in your jewelry, were all forcefully scattered into the void by these exact events. Without the violent, sacrificial deaths of these ancient, massive stars, the universe would be an incredibly boring, sterile place, filled with nothing but simple clouds of hydrogen and helium. There would be no rocky planets, no complex chemistry, and absolutely no biological life capable of looking up at the sky and wondering where it all came from. So the next time you find yourself standing outside on a quiet, crisp evening, take a long, deep breath and look up at the stars. While the vast majority of them appear completely serene and eternally unchanging, remember that a few of them are actively inching toward a spectacular, magnificent conclusion. And if the light from one of those ancient, violent endings ever happens to reach your eyes, you will know exactly what you are looking at. You will not merely be seeing a distant explosion, but rather the beautiful, necessary process of the universe recycling itself. It is the ultimate cosmic lullaby, a story of a star that patiently held itself together for millions of years, violently surrendered to gravity in a fraction of a second, and finally scattered its glowing ashes into the dark to help build whatever comes next. And as the brilliant light of that ancient explosion slowly fades from our sky, the universe quietly continues its unhurried, magnificent work, deeply at peace in the endless dark.